A warm welcome to all of you. It's been a long time since I've met some of you in person, and I'm very glad that we can all be together here to talk about a very important topic about the future of Singapore, the future of Southeast Asia, and the future of the global energy transition. So I'd like to put on record quickly my thanks to my university counterparts, University of Tromsø, and also, of course, Innovation Norway and the Norwegian Embassy for making this event happen. I don't want to take up too much of your time, so I'll just pass the mic over to Per Christer.
Thank you very much, Christopher, and welcome to this third day, actually, of the annual Norway-Singapore Science Week. Without further ado, I'd like to invite first our new ambassador to Singapore, His Excellency Eivind Homme, to give some welcome remarks. I think you can do it.
Distinguished speakers and participants, dear friends. Good morning to those following us directly from Norway, and good afternoon to you that are here in Singapore. His Excellency Sam Tan, Singapore's Special Envoy to the Arctic, Dr. Dag Rune Olsen, President of the Arctic University of Norway, and Dr. Philip Andrews Speed, Senior Principal Research Fellow, National University of Singapore. First of all, thank you to good colleagues in Innovation Norway, and in particular our Science and Technology Counselor, Dr. Per Christer Lund, for organizing this and for bringing us together here today. As a newly arrived Norwegian ambassador, I think it's the 2-month mark today, in fact. I'm in particular happy to be here to meet all of you. And next time, I hope it's possible to mingle and eat together and also to travel. So, dear partners, the point of departure for today's conference and the one concurrently taking place in Glasgow is that the Arctic is undergoing immense change. According to the Arctic Monitoring and Assessment Program, the Arctic warmed 3 times faster, and I say that again, 3 times faster than the planet as a whole from 1971 to 2019. So, due to the melting sea ice, the increased ozone surface is absorbing more heat from the sun and accelerating the melting of ice and the rise in temperature. Particles of plastic originating far away from the Arctic are carried by winds and currents and ending up in the Arctic Ocean. And the number of particles measured in some parts of the Arctic Ocean bottom is the highest in the world. This example, just to illustrate how our planet is interconnected system and how the Arctic is affected. I can assure you, the Arctic remains on the top priority for Norway. Some 10% of our population lives north of the polar circle. It's not somewhere else. It's where we live, it's where we thrive, and in fact also where my own family comes from. And the region contributes significantly to the Norwegian economy. And around 80% of all maritime traffic in the Arctic passes through Norwegian waters. Our future in the region depends on knowledge, bold decisions, and our ability to adapt. And I indeed add to that on on international cooperation. That's the way we can succeed. Dear partners, you know, that what happened on the top of Europe in the Arctic does not stay in the Arctic. The Arctic plays a key role in the global climate system, and developments there impact the rest of the globe. Singapore knows this. I've already been here, as I said, 2 months, but it's remarkable what I noted of Singaporean interest in the developments in the Arctic. That's include when I had the great honor to meet the President of Singapore last week to present my credentials. And this is evident in the Arctic Councils, which turned 25 years old earlier this year. So Singapore is already a long-standing, active, and highly valued partner in the Arctic region. Your participation demonstrates a foresighted and science-driven country choosing to engage out of long-term interest for your country and your region. So Norway has come to highly appreciate Singapore's involvement in the Council and the Arctic region. From engaging extensively in the Council's working groups, from engaging extensively in the Council's working groups to hosting workshops, expanding the Arctic Research Program, and sharing experience on Arctic issues such as climate change, biodiversity, and sustainable energy solutions. Allow me, dear special envoy Sam, that I just met for the first time, but I heard a lot about you, to pay special recognition and sincere thanks to you for your involvement and great contributions over many years in this regard. Dear friends, Norway, like Singapore, believes in the power of knowledge. Wise policy decisions must be based on scientific findings and expert advice. So Norway's approach to regional development in the Arctic is to invest in science, pursue sustainability, and trying to strike the right balance between protection and the use of resources. We have high scientific ambitions for Svalbard, and our government have over the years made substantial investment in its research infrastructure. We need academic partnership and international collaboration to succeed in the fight against climate change, for sustainable ocean management, and green transition and growth. Singapore and Norway have altogether 27 bilateral research cooperation agreements. And many of you have built close interpersonal and interinstitutional relationship between our countries. As such, I can conclude that we have a wide and we have a solid bilateral foundation for these efforts. I began these opening remarks by mentioning the melting sea ice in the Arctic and the rising sea levels. How will this affect climate and sea levels in other places, like here in Southeast Asia, close to the equator? The answer is of utmost importance, both to Singapore and Norway. Norway is home to world-leading academic environments of climate change, oceanography, ocean modeling, and satellite technology for land and ocean surveillance, to mention just a few. Critical knowledge for forecasting future sea level rise in Singapore and elsewhere. And today, we will also talk about green energy solutions. So Norway is prepared to further step up such cooperation with Singapore. And you are the key actors in making this happen. So the annual Norway-Singapore Science Week aims to be a platform for getting to know each other even better, learning from one another, and exploring together challenges and opportunities. Just like, and I know some of you were there, the Singapore-Norway Innovation Conference 2 weeks ago, which brought together companies from both countries with a focus on sustainability, decarbonization, and circular economy. So, to conclude, with over 2 governments' high ambitions, outstanding academic and research institutions, and innovation-driven companies, Singapore and Norway have a great potential for making a big difference together. I wish you a very productive conference today, and I thank you for your attention. Thank you.
Thank you so much, Ambassador Homme. As you know, this hybrid event is a partnership, as you mentioned, a partnership between Innovation Norway and the Norwegian Embassy, the Arctic University of Norway, and the Energy Studies Institute at the National University of Singapore. So I would like to invite you, Philip Andrew Speeds, Senior Principal Research Fellow at the Energy Studies Institute, to give a welcome remark. Please, Philip.
Thank you, Per Christa. Ambassador Homme, Minister Tan, Professor Olsen from UIT. It's a great pleasure to be with you, and particularly with the Royal Norwegian Embassy yet again. And I use the word yet again advisedly, because Ambassador Homme, you are the fourth ambassador that we have worked with. The first was Jana Julsrud, who, by the way, I met and shared an evening on a wet and miserable prawn boat in Oslo Harbour at the time of an IEA OPEC meeting. But she enlivened our evening, at least for my wife and I, as we got wet. Anyway, more seriously, the first event we held with the Norwegian Embassy was in 2011, November, precisely 10 years ago. It was actually on renewable energy and energy efficiency. Part of today's theme, but now modernized. And a rather younger Per Christer Lund flew down from Tokyo to give a presentation on CCS, a technology that still is yet to be mastered properly. Our first conference on the Arctic was actually a year later in 2012, which we did by ourselves without an embassy. And of course, in 2013, Singapore became an observer to the Arctic Council. And then it became a bit quiet. But then from 2015 onwards, with Ambassador Tormod Endresen, the energy picked up again, as it were. Initially, again, Per Christer was now here, looking at how the Nordic model of energy cooperation would apply to Southeast Asia. And that launched several, 2 or 3 years of research and track 1.5 meetings. But more importantly and more relevant was 2016 onwards. Really, that's when ESI picked up the Arctic baton under the leadership of Dr. Christopher Len, who you met at the beginning, who has been driving all of this, hosting meetings between ASEAN and Arctic member states here, going to meetings, having visitors, and participating in conferences, and of course visit to UIT with Minister Tan, and the signing of an MOU between UIT and NUS in 2017. So we have a long history, and then, of course, Anita Nergard arrived as ambassador in 2017, as was Paul Kastman, arrived around then, so there was new relationships to build, and we continued the activities, really, until the pandemic stopped it. And, of course, with Anita, there was also all the serious work was accompanied by a generous flow of excellent wine and food. Ambassador Homme, please note. So anyway, when that all picks up again. So it's great to be with you and really picking up the theme from the very first conference that we held with your embassy 10 years ago of the energy transition. But today, looking at hydrogen, which then was but a dream, now is starting to become a reality. And again, the nightmare of the Arctic melting, which the ambassador has mentioned. So we have two critical topics to engage with, and I think, and it's great that we are continuing our collaboration and building further on our collaboration with UIT. And I look forward to the discussions to follow. Thank you very much.
Thank you very much, Philip, for that, the summary of the history going up to now. That's great. I have the honor to introduce our keynote speaker, Mr. Sam Tan, Singapore's Special Envoy for Arctic Affairs. So, Mr. Sam Tan, you have had many key positions in the Singapore government. The list is endless, and I just have to pick something here, including Minister of State for Ministry of Culture, Community and Youth, Ministry of Manpower, Ministry of Foreign Affairs, and at the Prime Minister's office, and the last one was the Ministry of Social and Family Development. Amazing. You was pivotal when Singapore joined the Arctic Council as observer in 2013, and I believe you have visited the Arctic and Norway many, many times since then. Good friend of the Arctic and good friend of Norway. So we asked you to give us share with us your reflections of Singapore's engagement and interest in the Arctic. Please, Mr. Tan.
It is really an honor and a privilege to be here, particularly after moving into retirement for more than a year. So this is my first time speaking to the public. And as you know, that when a politician, particularly an ex-politician, get an opportunity of holding to the mic, usually they will not let go of it. So I beg your pardons in bearing with me if I make a long speech. Indeed, for such an important occasion, it actually warrants a speech that is long and significant because there are so many things to address. And as a result, I have prepared a speech that is as long as 16 pages, so I just beg your indulgence. So, Norwegian Ambassador to Singapore, His Excellency Erving Homer, and Singapore Ambassador to Norway, His Excellency Tan Hua Yao, who is actually attending virtually from another location. Although his physical body is not here, but his moral support is always with us. And Excellencies, distinguished guests, ladies and gentlemen, a very good afternoon to all of you. And it is indeed my privilege and pleasure to join our distinguished overseas and local researchers and experts of sustainable energy and climate change here today at this very meaningful conference. And let me first express my deep appreciation to the Norwegian Embassy, the Arctic University of Norway, and the NUS Energy Studies Institute for organizing this very significant and meaningful event. And Singapore and Norway are like-minded partners. We enjoy a very warm relationship, which is underpinned by strong maritime and economic ties. We also cooperate closely on Arctic-related initiatives, including those at the Arctic Council. It is therefore befitting that my last Arctic-related visit in my previous capacity as Minister of State in the Ministry of Foreign Affairs was to Tromsø for the 14th Arctic Frontiers Conference in January last year. And today I'm very humbled by the honor of delivering this keynote at this conference organized by Norway in my new capacity as Singapore's Special Envoy for Arctic Affairs. Ladies and gentlemen, 2021 marks Singapore's 8th year as an observer in the Arctic Council. When we first embarked on our quest for observership at the Arctic Council in 2012, many people were puzzled about Singapore's interests in the Arctic. They asked, what commonalities do a hot tropical island 7,000 kilometers away from the cold and icy Arctic share? So what is the common interest? The truth of the matter is that the Arctic is a globally significant barometer of changing climate patterns. The future of the Arctic's environmental well-being is critical for Singapore, Southeast Asia, and the rest of the world. As Ambassador Homer mentioned just now, that what happens in the Arctic doesn't stay in the Arctic. And I would want to hastily mention this, that whatever happens outside the Arctic does not stay outside the Arctic. Because the world is closely linked through climate and weather. So anything happens in any part of the world will have some impact on the rest of the world. So the well-being of Arctic is not just the sole concern of people and countries living and located in the Arctic region. It's also a global responsibility of every member of the international community to make sure that we do our part to make sure that the Arctic will not melt away. So Singapore therefore sees the need for stronger international collaboration on sustainability initiatives amid the climate crisis. As Prime Minister Lee Hsien Loong said at the recently concluded G20 summit, and he reminded us that climate change remains the existential challenge of our times. And recent research has also revealed that Arctic warming is happening 3 times faster than the rest of the world. I remember in 2012, 2013, when I started involving myself in discussions related to Arctic affairs. At that time, we were reminded that Arctic is warming twice as fast as the rest of the planet. And in less than 10 years' time, and now we are hearing that Arctic is warming 3 times as fast as the rest of the world. I think this is really a very alarming development. And in fact, it has been predicted that the sea levels could rise up to 1 meter globally towards the end of the century, this century. And as a low-lying country like Singapore, we are especially vulnerable to the effects of climate change and also the rising sea levels. So this is the sobering fact is that melting polar ice caps pose a threat not just to the immediate surrounding regions, but also to low-lying islands and countries such as Singapore and other countries. So we ignore this existential challenge at our own peril. And as a small maritime nation, situated at one of the most important shipping lanes in the world, Singapore is also interested in the possibilities and opportunities for international shipping that the opening of the Northern Sea route presents. This new route will shorten the current shipping routes between East Asia and Europe by about 40%. These developments will bring about new opportunities. As climate change accelerates, it has spurred innovation for new ways to support growth while reducing our carbon footprint. For instance, there is an urgent need for all countries to shift towards cleaner sources of energy. Over the past decade, Singapore has switched from fuel oil to natural gas, which is the cleanest fossil fuel. Natural gas now takes up 90% of our fuel mix for electricity generation. By 2035, Singapore plans to import 30% of energy from low-carbon sources. We also, at the same time, seek to innovate in the domain of sustainable energy, which our distinguished speakers will further elaborate on shortly. So the use of hydrogen as a low-carbon sustainable energy source has generated quite a bit of buzz in both Singapore and Norway. And Singapore is actively studying and investing in advanced low-carbon solutions such as carbon capture, utilization and storage technologies, as well as hydrogen. We also have an ambitious plan to quadruple local solar energy productions from 2020 levels by 2025. That is, in 4 years' time, we're going to increase the local solar energy production. Ladies and gentlemen, there's a lot of scope to unlock the large and mutually beneficial economic opportunities as we push for decarbonization and sustainability. And international cooperation is also key as we work to improve the environment integrity of carbon credit markets around the world, scale up green opportunities, and manage potential cross-border spillover of carbon pricing and related measures taken by individual countries. And over the past few years, Singapore has invested almost $50 million Sing dollars to develop low-carbon energy technology. And we have also commissioned studies to begin examining the feasibility of using hydrogen as a fuel. Through these studies, we have begun to identify the challenges of this alternative energy source, such as the difficulty of producing green hydrogen at scale and also using domestic green electricity. It is therefore my hope that we can begin to overcome these challenges through international knowledge sharing and exchanges at conferences like this. Ladies and gentlemen, the impact of climate change on the Arctic ecosystem has been severely felt over the past year, with 2020 being the second warmest year on record for the Arctic region. Hence, it is necessary to strengthen global scientific cooperation and collaboration, and conferences such as these today help in developing our understanding of the rapid changes impacting the Arctic. And Singapore's Institute of Higher Learnings undertake research in Arctic technology, including facilitating remote energy access in the Arctic. Of note, the National University of Singapore's Technology Center for Marine Offshore and Marine contains a deep ocean basin facility, which has the potential for Arctic research applicability. We also set up the Center for Climate Research Singapore to enhance our understanding of the climate science, including how climate change in the Arctic affects polar ice sheet. I look forward to hearing the latest findings from my good friend, who is an expert on the polar ice sheet, Professor Ben Horton from Earth Observatory of Singapore, in this segment later. Since joining the Arctic Council as an observer in 2013, Singapore has been supporting the sustainable development of the Arctic, including through active participations in various Arctic Council working groups, and also sharing Singapore's practices and knowledge in areas such as oil spills, conserving biodiversity, marine shipping, maritime litter management, and sustainable energy development. In addition, we continue to offer a technical cooperation package to enhance human resource development and governance capabilities for the permanent participants of the Arctic Council. And Singapore looks forward to closely working with the Russian chair to contribute meaningfully to the work of the Council. And looking ahead, Singapore seeks to further contribute to the Arctic region in a few ways. First, we look forward to promoting greater youth engagement on Arctic issues, since it will be of increasing concern over the course of their lives, and to raise awareness on climate action and sustainability issues among Singapore youth. The Singapore Ministry of Sustainability and the Environment initiated thematic years on climate actions and zero waste. It also organized Singapore's Climate Action Week in August 2020 to encourage collective sustainable actions by Singaporeans. And just last year, Singapore launched the Singapore Green Plan 2030. This is the whole government sustainable development agenda to strengthen Singapore's commitments to achieve our long-term net zero emissions aspiration as soon as viable. And beyond youth engagement, Arctic-related research will continue to be a priority for our engagement with the region. It is important for policies in the Arctic to be supported by science-based research, and further studies will support such an endeavor. And as an observer state of the Arctic Council, Singapore is committed to contributing to a better understanding of climate change and its impact on the Arctic. And we look forward to collaborating with international experts across the research community on global efforts in adapting to climate change. We also want to find avenues for making Arctic science research inclusive and engaging for the future generations, as global climate change will impact them most. And finally, I look forward to an afternoon of inspiring and engaging discussions, and I wish all of you a fruitful conference. Thank you very much.
Thank you so much, Mr. Tan, for this fantastic, not only backdrop of the history and the history of Singapore's engagement in the Arctic. I think many people are wondering why, as you said, a country here has such an interest, and I think Mr. San is the one that said that Singapore is the country in the world that is closest, actually, to both poles. But there is also other elements, and you kind of draw the big picture of the challenges, but also the opportunities and encouragement for working together in international research communities. There are big challenges that has to be met in cooperation. I have the pleasure now to inviting Professor Dag Rune Olsen, the president of the Arctic University of Norway, also known as Tromsø University, or UiT, to give your greetings for this meeting. So Professor Olsen is a professor of biomedical physics with special expertise in cancer research. But you just came to Tromsø from the position as president of Bergen University. I think this was beginning of August this year. So, Professor Olsen, would you give your introduction or presentation on this Arctic event, please?
Thank you. Your Excellencies, colleagues, good friends. Even though I would, of course, much love to be with you today, the current situation with the pandemic doesn't really allow that. But it would have been much nicer to sit around the tables and talk to you without these utterly silly headsets. But I'm sure that the world will sooner or later normalize and we can pick up again on the more ordinary ways of conducting collaboration and fostering the mutual dialogue that we are so heavily dependent on. And not at least in academic or amongst academic institutions. Yes, I arrived in Tromsø not that long ago. 1st of August, I took office after serving as president or rector, as I call it, at the University of Bergen. But I have been visiting Tromsø over the years, and Your Excellency Sam Tan, I've actually had the privilege of meeting you twice here in Tromsø during Arctic Frontiers. And I'm really happy to see that you now continue to take a keen interest with respect to the Arctic, but now in a different capacity as the special envoy. Your initiative and enthusiasm is highly appreciated. I think it's fair to say that the collaboration between UiT and Singapore, and then not in particular, of course, the National University of Singapore, a highly ranked and acclaimed university, took off really after the state visit to Norway, where the Singaporean President, His Excellency, came to Norway, and with our King, the both head of states came to Tromsø. That was in October 2016. It's not like that collaboration between universities or academics necessarily need a head of state visit to take off. But after that visit, as we've heard, agreements were signed, and that was of high value for us with respect to the collaboration. We have appreciated a lot also the previous ambassadors' initiative and hard work for helping out with respect to the collaboration. Anita Nergård has been mentioned, and we have great expectation to Your Excellency, the new ambassador of Norway to Singapore. I think that one of the most important things, people to people, state to state can collaborate over is actually higher education and research. And of course, with respect to today's topic, the research with respect to climate change and the energy transition is of utmost importance, not only to the universities, not only to the two countries involved, but simply for the globe. I'm also very happy to say that together with NTNU, Sintef Ocean, Sintef Community, UIT has co-financed the Council of Position at Innovation Norway in Singapore. That has been working out extraordinarily well, and that is also a functioning mechanism that can facilitate collaboration between academic institutions in a much more efficient way than without. So we have very good experience with that and hope we can develop those kind of mechanisms further. From our university's point of view, the collaboration has been of great value in a variety of topics, from law of the oceans, for example, but also in natural sciences, technology, but even also in medicine and aquaculture, to name a few. And those topics are, of course, very important for our university. But let me perhaps draw our focus to today's this session's topic. We are talking about the necessity of energy transition, and the reason is obvious. We all know it. It is the climate change, the temperature rise that we see with the consequences that has globally, which is quite serious. And that's why also we now have the COP meeting in Glasgow, where I'm happy to say that Norway's Minister of Climate and Environment is working together with Singapore to lead the negotiations with respect to Article 5, and that is related to the trade-off quota. I mentioned this to say that our two countries collaborate strongly, and it's also like that the energy transition and the way to combat climate change is not merely through new technologies and energy resources, but it is also a more comprehensive approach that is needed, where all academic disciplines need to be on board to tackle this challenge. And we should also, as academic institutions, provide advice to our politicians, decision makers at a variety of levels that has an impact on the development with respect to the energy transition and the climate change. Some years ago, at the time president of the UN General Assembly, Peter Thompson, he wrote to leaders of higher education institutions, universities, research institutions, and made them aware of that the UN the General Assembly had adopted the Sustainable Development Goals, the SDGs, and urged us to take on responsibility for introducing our students and research staff to the goals and see how could we as academic institutions how could we contribute. And of course, it is in particular of relevance to this session. It's the combating climate change, which is important, and the other SDG, clean and affordable energy, I think is a nice backdrop for what we need to discuss. At our university, we have embarked on a quite, let's say, extensive sustainability agenda. Agenda 2030, which is relevant for our educational programs, is important to mention, but also our research, which will, at the end of the day, contribute together with other institutions like the National University to come up with solutions that could possibly lead us through the energy transition in a way that is also acceptable to society. more perhaps than ever talk about the just transition, because if we're going to make this transition happen without societal unrest, it has to be a just transition, and that means that we need to introduce the energy shift in a smart way that is acceptable to society, to individuals, to people. I think that there is a role for academic institutions coming up with new results, new insight, new technologies, but also suggest ways to introduce new energy systems or see to it that the transition can happen. As Sam Tan also alluded to, it has to be, and the ambassador alluded to, it has to be based on knowledge, based on science, based on insight. And universities are there in the midst of that, and it's part of our, at least what I regard as our societal role to contribute with and to learn. It has also been mentioned that where I am, my university in the Arctic, where we're located, well, that is the place on the globe where we can feel, see, observe the consequences of climate change at an early stage. Climate change with the rising temperature is highly present here in the Arctic. And it has severe consequences on the ecosystems that we see on land and in the seas, and also consequences on life and society and individuals. But of course, as also mentioned, the sea level rise has consequences for land where millions of people live, not only in the Arctic. We see severe consequences related to the sea level rise in a variety in various places on this globe, and Singapore is obviously one of them. We also see that acidification of the oceans and increased temperatures has severe effects on the ecosystem, the marine ecosystems globally. Yes, the consequences, well, we can observe them at first hand here in the Arctic, but that does not mean that it stays in the Arctic. It has global consequences. So I think what we observe up here will at a later stage be just as important for other parts of this globe, and that's why we are in this together. In order to combat climate change, a number of measures has to be taken. I already mentioned the trade of quotas, Article 6, where our politicians, Singapore, Norway, lead negotiation on this in Glasgow. But I also think that as academic institutions, we need to come up with at least suggestions for new technologies that can reduce energy consumption, new energy sources that are renewable, but also look at the infrastructure, the grid, the energy system that can contribute to an even smarter use of our energy resources. I think that obviously off-grid, smart grid solutions are important, and new energy resources, as we've already heard about, the hydrogen societies is important as a component of the solutions that we need to come up with. But I also think that not only the energy side, but how we can also take care of the CO2 emissions that is ongoing, how they can be reduced, obviously, but how we can also see to it that the CO2 doesn't necessarily only pose a problem, but it can also be of value. And I'd just like to mention a small project that I find quite interesting here in Tromsø. It is a CCU project where CO2 from a plant is used to grow algae, which in its turn can produce omega-3 fatty acids. And that is a very important ingredient in the fodder of farmed salmon. In order to produce a product with high nutritional value, omega-3 fatty acids are crucial. And there is a lack of that globally. So in order to contribute to feeding the world, the protein resource or the protein source of the oceans is extremely important in the years to come with respect to feeding the globe. But then we also have to come up with nutritious alternative from the seas and oceans. And if we can utilize CO2 to have a much better for the farmed salmon, that would be helpful, both with respect to the CO2 problem, but also with respect to healthy and nutritious food for the globe. Well, I'm really looking forward to the talks, and with that, again, I would have liked to be with you. Not possible this time, but good luck with the rest of the discussions throughout the seminar, and I'd next time see you in Singapore. Thank you.
Thank you very much, Professor Dag Rune Olsen, President of the Arctic University of Norway. Now let's move on to the first panel. I have the pleasure of introducing that panel on the topic of energy infrastructure challenges in off-grid societies with captive renewable energy, such as in the Arctic, but also similarities to the island societies here.
Per Christer, you are muted.
I am? That's
Matteo, det du som skal snakke nå, tror jeg, og du muta.
Yeah.
Ja, men også Per Christer er muta.
Ja, men det er han som har gjort det.
We'll try to find a solution to this.
Jeg tror du bare skal starte.
Ja.
Hello? Can you hear me now?
Det er bra, Per Christer.
Yes, Per Christer.
Yeah, but I think, Rodney, you have to unmute your... Can you hear me now then? This is the most common phrase now these days, isn't it? You're muted. Can you hear me?
Do you guys see my presentation?
Just hold a second.
Hello, everybody?
Yeah.
Do you hear me?
Can you hear me now?
We can hear you, Per Christer.
All right. Okay, sorry for that technical thing. Are you... Okay, now it's okay?
Yeah, it's okay.
All right, okay. Yeah, so I just repeat what I said. Thank you very much to Professor Dag Rune Olsen. Great presentation. And we were talking about introducing the first panel on the topic of energy infrastructure challenges. We have quite a few presentations today, universities, institutions, company engaged in the Northern region and ASEAN. I have the pleasure of giving the microphone over to my colleague here, Christopher Len, Senior Research Fellow at Energy Studies Institute, NUS, to moderate this panel. So please, Christopher.
Thank you very much, Per Christer. I assume you can hear me from Norway. It's okay to take my mask off. Yeah. Okay, so I'm moderating this session. We have we have 6 speakers. We have until 5:30. We may not need to go all the way. We may just take a quick 5-minute break before the next session starts. So with 6 speakers, I would like to request that the speakers keep their presentation to around 10 to 12 minutes. And then after that, we will have the question and answer. So without taking too much time, I would like to invite the very first speaker now, Professor Matteo Chiesa from University of Tromsø. He's going to talk about the hydrogen projects in Norway. So you have 10 minutes. Please go ahead. Thank you.
First of all, thank you for the presentation. And very difficult to ask a professor, especially me, to be within 10 minutes, but I'll do my best. That would be the failure or failing the exam. Anyway, I'll try to provide some overview about hydrogen projects in Northern Norway. Now, who I represent, just to underline what my president was saying before, is an initiative at the university called ARC, the Arctic Center for Sustainable Energy, that try to coordinate and organize the activity across the university in order to develop knowledge and expertise that will aim at fostering an oil-free society. And we are very keen in talking about oil-free society, although we mean a fossil-fuel society. And a society to function needs renewable energy, or energy that comes from renewable energy sources, need transportation, and transportation is much more than a car. It's traffic by boat, by plane. We need to be much better capable of utilizing the resources that we have available. And then we need also to reuse, for example, a case and the example that Doug Gruner just mentioned about carbon capture and utilization. These are the verticals and the main type of topic that commons many researchers. We are circa 40 people dealing with this. And then the rest is more about data analysis. There is plenty of data, there is plenty of opportunity to do things in a more efficient way. And on the last side is material science. And in this respect, Singapore is very extremely good and very successful within material. But the core of the center is the social and philosophical questions. I mean, how do we place value to technology? How do we place a meaning that goes beyond the technology itself? And in this respect, due to the fact that I have a professor, being a professor, working at the university, I have the pleasure of not just going into what the task I had, which are the projects related to hydrogen is, but giving a bit of a perspective. So technology, or the essence of technology, as Martin Heidegger says, is not technological at all. So that implies that the meaning and the value and what is the role of a technology is by far not a question that belongs to people like me that develop a technology, but more about how do we apply, how do we put it together. And by nature, I'm somehow very impatient, and I see that there is a lot of talking. And what I'm saying is that the technology is actually very much available. There is a lot of technology that can be put together and can, in fact, solve the issue that we are facing with global warming and climate change. But sometimes we do not put the right value on technology. For example, this is a very nice example that I like to share with everybody, but it shows the political value versus the really epistemic value of a technology. In the 60s, we had a full functioning thorium reactor at DOE. And at that time, the president of the Department of Energy in the US was actually thinking that this was the right way to harness nuclear energy for civil application. The reason why this is not implemented or has not been implemented thereafter was because out of this process, you cannot, the leftover cannot be used to create bombs. So you understand that at the end was not the technology that failed, was the political agenda that made the technology fail. So here, therefore, it comes again what I said earlier on about the creating technology that is human-centered. One of the, for example, experiences we're having in Norway is the hate for the technology that helps harnessing some of our resources, for example, wind, into electricity. But nevertheless, let me go to what the topic of the discussion is. And Norway has had in the last few years an agenda of electrifying its society. We've been very active in several projects, especially in the Arctic, or where the university is located. And the idea is to be able to add part of or new technology to the system in order to enhance the capability of the current technological or transmission system to tackle the development that these regions are facing. For example, in this case that you see is a project on a nearby island that faces or that has faced a huge increase in fishing industry, and therefore it requires more electricity of high quality, and that sometimes cause some challenges. Other thing is just facing, and there is the resources are available, resources need to be matched with the demand. For example, solar is a good resource in northern Norway, but in the summertime. So do we find something that can utilize that type of resource in the summertime? And for example, a very good example is a cruise ship, cruise coming up north that still are at the harbor, and they have the auxiliary motor running, and these are usually 5 megawatt or in this size diesel engine, and all this electricity, especially due to the fact that these boats are coming in the summertime, could be met by renewable. Anyway, so the idea and the solution related to hydrogen and related to these is a recognition that indeed this part of Norway, in general all of Norway, but the northernmost part of Norway, the Arctic part of Norway, is blessed with a huge amount of natural resources. And usually it's difficult to create added value out of these resources due to the fact that either they are far away from where the demand is. So hydrogen in that respect, it could be a way how our region can create activities with the consequences that activity has, because activity comes with a footprint, but doing that, minimizing on a global perspective the footprint that we may have. And in this respect, hydrogen. And I would like to hear in a Norwegian context, we talk about blue and green hydrogen. And in a European context, if you extend to our nearest neighbor, blue hydrogen is not even mentioned, because blue hydrogen would imply the European continent to still import gas from, for example, Russia. Anyway, the northern part of Norway is blessed, as I told, with resources. Here you see a map of the electricity price some days ago, and it's widely available on Nordpol. And you see that it's €19 per megawatt hour in the northern Norway, or in our region, northern Sweden, while it's 10 times higher in Germany, France, and almost nearly everywhere, and even in the southern part of Norway, where there is a more connection with the continent. So hydrogen could actually be a way to transfer these resources. I mean, the reason for that price is because you have more resources than the demand has. So how can you transfer that green energy elsewhere? And hydrogen in this context, or any of the hydrogen-based fuel, can be a solution. One of the projects is in Bellevåg, where it's the extreme north of Norway, where you have wind resources that are amazing. The wind farm up in Bellevåg, owned by Varangerkraft, has a capacity factor of nearly 50%. It means that it delivers electricity with a capacity of with a design capacity for 50% of the time. This is usually unheard for renewable energy technology. The issue of Varangerkraft and of this Raggovidda Kraft power plant is that their energy cannot be transported. They produce more than what they can transport due to the limitation of the grid. And therefore, they've started thinking of hydrogen, thinking of ammonia, thinking of how the production of hydrogen locally would also result in the production of heat, and the production of oxygen. How can these resources be locally utilized? Now, from an export idea, obviously in the long term, the large-scale production, especially when we're talking about ammonia as a carrier, which, by the way, ammonia is the carrier of hydrogen that uses pretty much 95% of the hydrogen produced worldwide. And it's not used for transportation, it's not used for energy, it's used for other chemical processes. But anyway, what we are trying to put on the table or establish a discussion, if we want to create a hydrogen economy or an economy based on hydrogen in northern Norway, due to the fact that there are certain activity like the transport by truck, the transport by ship that cannot be as easily electrified, it would be probably more effective to utilize the availability of a 24/7 really cheap electricity and store and distribute locally. Here, there are some other aspects related on safety and this kind of stuff. And the standard requirement are very similar to what one expects for large-scale activity. Here we're talking about, for example, a project connected to the one that I explained before, trying to provide the energy to Longyearbyen that up to now has been usually energy related to coal power plant. There are plenty of other small community on Svalbard that are fed by electricity produced locally by diesel engine. And they could, if you look at the fact that they are mostly used throughout the year, but a lot of the people coming and doing activity is in the summertime, where actually the solar availability is quite big. This is another big project about TECO 2030 that aims at producing fuel cell for the utilization of the hydrogen that it's popping up. It's going to get produced due to the advantages I was telling you about. And TECO will start building a factory out of Narvik, and it will produce 1.2 gigawatt of fuel cell capacity. Another thing that is slightly different but still related is the factory or battery factory that are thought built in Mo i Rana and throughout. Here we see some other of the activity, for example, that the university is having with fuel station, hydrogen fuel station, and these allow us as a university to try to target specific challenging in our specific environment, which is the Arctic. Now, obviously, these require, the availability of hydrogen is one thing, but also you need to have a market to be able to utilize that hydrogen. And the government has been very active at that, for example, at leveraging on new purchase of local ferries that are driven by hydrogen. And in one or another way, technology is actually widely available. The idea is now in a synthetic approach, taking the technology, putting it together to create a solution that can be viable for the specific condition you are facing at. There are a lot of transitional possibility of this research, this know-how to other sector, but I think despite I have done it available. So it's about us moving our ass and getting implemented more than talking. And I stop it here.
Thank you very much for the presentation, for reminding us about the human dimension in the diffusion of technology, and also for updating us on the developments for hydrogen in northern Norway. So next, I would like to introduce Dr. Lars Brenner. I hope I pronounced your name correctly. He's the head of processing and mechanical technology from Horisont Energy AS. So he's going to talk about the production and export of blue hydrogen and blue ammonia from Barents Sea. So please go ahead. Thank you.
Thank you very much. Can you hear me? You can
Yes,
hear me?
yes, we can hear you. Please go ahead.
Thank you. No, your spelling of my name was very perfect. Thank you. I'm just making the contrast with the background picture from Singapore, and I will come back to it. And what you see on the screen is our project that we are running at the moment. And I'm working on the processing and the mechanical part, and will give you now an introduction to our project. And this is an ongoing project that we are doing at the moment. It's called the Barents Blue Project. And yeah, you maybe it's slower at your side. So to introduce you to this project, what we are doing now, we have been discussing about green products, and this is a blue product. So basically what we are doing, we are located in the northern part of Norway, and in Norway we are producing hydrocarbon gas. So, and today in this area we have available gas that is used as liquefied natural gas. And what we are doing, we have a project where we want to utilize this gas consisting of carbon and hydrogen as a methane and similar compositions of the gas that we convert into ammonia. So hydrogen first and then ammonia. So just to give you an introduction to that, so if you look, this is we have reservoirs under the seabed where we actually extract today hydrocarbon gas. This is where the carbon is coming from, together with the hydrocarbon gas. And in this project, we are then getting the gas, it's shown to the right here, arriving our plant, where we split this gas into the components, so we're able to make CO2 and hydrogen. And in this way, we can create ammonia, because the nitrogen we get from the air and mixing with the hydrogen gives the ammonia. And the CO2 is then captured, 99% of all CO2 that is part of our project to have carriers that are transporting this and doing injection back to the reservoir. So where we extract the carbon, we are putting it back again as a carbon capture and storage. And the whole project that I'm presenting today is including, we have a pipeline from the existing gas plant where it's available. It's the plant itself that is a world-scale ammonia plant with 1 million ton per year. And I think this is actually one of the largest one, and this is the first, what we call the first train. The first step in the project will be, we are aiming for 3 trains, so 3 times this amount. In hydrogen, this number, what is shown here with ammonia, consists of about 200,000 tons of hydrogen a year. For the first train. So this is a large project. The CO2, as I said, is transported and injected, and then we also developed a technology that is we are familiar with in Norway when it comes to drilling and reservoir engineering as a part of our project, and also the transportation of ammonia and distribution of it. And the capture rate on the CO2 is 2 million ton per year for each train. So it's so in this way, by capturing 99% of the CO2 that we produce from, let's say, the gas to create the ammonia, this is captured and then stored. And as a part of our project, we are partners with Vår Energi Equinor on the ammonia plant, and for the license and the operation for the license where we do the injection is together with Equinor and together with us. I will not say too much about this, but we are a company located in Stavanger, so I guess you don't know where Stavanger is, but it's on the western part, southern part, so the climate here is about, let's say, 10 degrees all the year around, 10 to 15. We are a company with 22 people, and we are developing and running fast on this project to develop all these technologies, components to be able to do this project. This is just some news from recent work. So why ammonia? Why are we working on ammonia? Ammonia is, if you look on the cost compared with hydrogen on the right here, you can see that the cost to transport it, so the cost per kilometer and ton is smaller, so it's more efficient to transport it as an energy source. And also from the energy perspective, with a certain volume, you are able to have more energy compared with hydrogen. So, and our target is, of course, to supply blue ammonia, so clean ammonia, for the future fuel for the maritime sector. So this is for all the ships and boats to replace it with diesel and other fuels. Yeah, so this is a part of it. And then the distribution is also quite mature, so existing and understood from the use. It's also to be noted that the ammonia that consists of nitrogen and hydrogen as a molecule, you are able also to split it later on to bring the hydrogen. Yeah, so it's a carrier of hydrogen actually.
Sorry for this disruption. In this case, I'll just move on to the next speaker instead, yeah? The next speaker we have is Mr. Benny Suryadi, Manager at the ASEAN Center of Energy from Jakarta. Benny, can you hear us?
Okay, I think there are some internet glitch, so I just, as requested, I will continue the session. So thank you very much, Dr. Christopher Len, Dr. Per Christers. Hello, everyone. Warm greeting from Jakarta. So I'm excited to join with all of you in this important discussion. And my highest appreciation to Innovation Norway, Singapore, and ESI for inviting me to represent the ASEAN Center for Energy, sharing the insight on hydrogen development in the Southeast Asia. As per the title, given that I'm going to speak from this perspective of our recent studies that was released several months ago, and also try to touch a bit on hydrogen as an energy carrier in the Southeast Asia. But a short introduction. So I'm working for the ASEAN Center for Energy, where we are representing the interests of the 10 countries in the Southeast Asia region. And one of the projects that we are implementing is the ASEAN Climate Change and Energy Projects that aims to improve the coherence between the ASEAN energy and the climate policy, contribute to the more climate-friendly development in the region. So this is funded by a Norwegian government under the Norwegian ASEAN Regional Integration Program, which we jointly implemented with the Norwegian Institute of International Affairs. So this is the regional blueprint. I just keep this, but you can read it later. I start with this result from the projection that
Sorry, Benny, can you hear us? Benny, can you hear us? I don't know if it would help to not share his screen.
Regional power grid or renewable energy investment, and also explore new and emerging technologies such as hydrogen. And I mean, referring to the previous presentation as well, and many literatures, we do realize that hydrogen is an important energy carrier, has many advantages. One of it is the energy intensity is higher than the gasoline, or can be also refueling can be done also quickly as gasoline or diesels. To some context, can be produced from clean and indigenous resources such as renewable or from a nuclear, biomass, and biofuels. The scale and location of hydrogen production are quite flexible. So I think with being showed previously on the location that one of the example of the location. And when the share of intermittent renewable is high, using surplus or abandoned renewable to produce hydrogen can not only balance the power grid, but also offer a kind of option to store energy when the weather is sunny, windy, or rainy, and release back to the power grid. So given this kind of opportunities to support the green energy development in the region, so we conduct studies called Hydrogen in ASEAN, Economic Prospect, Development and Application. So the study, high-level studies that also being presented to the minister meeting last September to be in line with regional strategy in addressing the energy transition. So we look on the application of the hydrogen in three sectoral. The first one on the hydrogen for the power storage. So based on the calculation that we have through various models, that we identify the cost of hydrogen for the power storage is still way higher compared to like lithium battery or pump hydro in all of ASEAN countries under the current condition. And then also the technology for utility scale fuel cells, it's gas turbine is also considered not commercially available, particularly in this region. Then on the context of transportation, this is also where we indicated that hydrogen application for like bus or truck is still also not economically attractive in the region. Some calculations show that it's still 3 times higher than the existing diesel bus or truck data. So it really is still at the condition is not competitive enough in this region. But one area that considered good enough is on hydrogen for the export market. We found that the gray hydrogen produced from the countries such as Brunei and Indonesia could already be competitive in the current situation. And if all the cost of hydrogen storage and transportation fall in the futures, gray hydrogen production could be upgraded to the blue hydrogen production coupled with the CCS, while still maintaining competitive level of supply cost to the overseas market. Then it's not really a firm action for us in the region, so that as we are trying to continuously embark the work on the hydrogen. So we are pursuing development of regional policy roadmap and strategy in the state-wise, looking from today until 2030s. Because as per our studies, that evident that policy have a substantial direct impact on competitiveness of the hydrogen studies. So dedicated policies such as tax, subsidies, and other incentive or disincentive for both the energy market, like or others for the vehicle ownership. And you said that favor the hydrogen could be very important to progress in technology and supply chains in order to bridge the cost gap as per the calculation that we found in our studies. So hydrogen has been produced and delivered mostly for the energy use at the demonstration level, demonstration scale in the region. So this implies that on one hand, the economic of scale and learning effect have not shown the power to reduce the cost of hydrogen supply yet. And the other hand, the infrastructure for the transportation and delivery of hydrogen at large scale for energy use has not been establishing. So a supportive policy framework with a long-term plan and target is critical if the regions really want to embrace the strategies on hydrogen. And learning from the presentation from the previous expert, I think many that ASEAN can learn from the experience from Norway and others. So I will stop my presentation here. Happy to have a follow-up discussion later. Thank you. Back to you, Dr. Christopher.
Thank you very much, Benny, for the very interesting presentation covering Southeast Asia. And now I'd like to invite the next speaker, speaking about Singapore, Mr. Andrew Bedford, Director of Energy Transitions from Jacobs Engineering. So please, I'd like to invite you to the stage.
So thank you for the invite, and yeah, it's great to be here, and it's nice to be out of the house as well. It's quite exciting for me, as I rarely leave the house at all now that my wife has discovered online shopping and the Red Mart. So I'm going to talk about hydrogen in more of an Asian perspective, not just Singapore today. So if we jump to the next slide. I'll probably skip over the corporate intro stuff, but Jacobs is a big global company. It's got lots of people and covers many sectors. So if we move to the next slide. And the one after this, I think. Thanks. So when we talk about energy transition at Jacobs, it really covers this here on this slide. It's the energy supply chain, it's the generation and renewables, it's nuclear and small modular reactors recently is a trend, it's energy storage, and then the transmission and distribution. And hydrogen is a bit like energy storage. It's quite a small market right now, but it looks like it's destined for major growth. And then there's all the downstream uses, some of which look easier to decarbonize than others. And hydrogen is an absolute, it's needed, it's a requirement or a feedstock for some of those sectors, whereas others, hydrogen is competing with other, alternatives like batteries for vehicles that looks like it'll give it a good run for its money. That's right. So when we talk about energy transition activity, I've picked out a few themes that keeps coming up in areas where we work. So we're very strong in water and wastewater treatment. There's lots of people asking about electrolysis and producing hydrogen and for their own use and energy, but also oxygen to feed into the aeration systems for the wastewater treatment works. That helps them increase the throughput from the plant. There's aviation in the UK working on some projects with hydrogen infrastructure for aviation. Lots of federal and environmental activity, people planning and permitting these new export projects, as well as the receiving end or for carbon capture projects. And then cities and built environment or advanced facilities. There's lots of these major global companies, well, everybody, I'd say all of our clients are on the same hymn sheet when it comes to decarbonization. So they all have the same goal in mind. The trick is how to do it. So when it comes to manufacturing facilities or data centers, they're trying to figure out how to incorporate rooftop solar, energy storage, as well as hydrogen fuel cells and things into their buildings. So it's a very different picture across sectors, but the same theme of sustainability, decarbonisation, and resilience as well. How do you adapt to climate change and make it more secure at the same time? The same themes keep coming up. So next slide, please. Good. Let's skip past this one. Yeah, I'll get to the subject. Yeah. All right, so no, that's great. It's great driving here. So it's the IEA came out with their path to net zero recently, and they said the spending on infrastructure across the energy sector needs to rise from something like $700 billion today to about $5 trillion by 2030. So it really puts the challenge that we have in perspective. And this is for that net zero 2050 target of 1.5 degrees. But the guy who actually came up with that number says, there's only a 50% chance of constraining global warming, even if we meet that target. So the challenge is large, and it requires major investment across all of these sectors. There's the public EV charging points, has to rise from 1 million today, all the way up to 40 million by 2030. There's the batteries you need for the vehicles. It's a huge increase in not just in the use, but also the manufacturing facilities of those batteries. So, and then I just want to point out, it's not just an energy transition, it's a resource transition. So you need all the rare earth metals and minerals to make the magnets, the motors, and the batteries themselves. So it is a big change in our resources market. When it comes to Asia, that is really sort of two tiers within Asia. There's the more developed economies of South Korea, Japan, Singapore is within that bracket, and then those countries that really have already or starting to decouple their economic growth from their carbon emissions, whereas South Asia and Southeast Asia, they have the other side of the coin. It's rapidly growing economies, rapidly growing populations as well. They have a real challenge to decarbonize. So some of those countries are also very reliant on oil and gas. So if demand does drop off, then they have to find jobs for those people who may be unemployed or affected or impacted in some way. So they get a double whammy. I see this as a tale of collaboration. You need partnership between the two sides of Asia, as well as globally. So the wealthier countries with these emerging economies that really where the growth markets are as well. I just put a few maps on here just to show that the status of the net zero targets, which countries have adopted them in law, and also over what sort of time frame. You can see Southeast Asia, and South Asia is a little bit grey on this map. There may have been some news this week or today that I've just missed at COP26, but really this needs to be in real time over this week or last week. There's been so many announcements, but really these targets, when they're in law, they're the drivers, they're the signals that the government needs to give out to make everything else happen. So once these are there in place, then the hydrogen strategies on the next slide, they start to emerge from regional governments as well, if not the state. And that's really the signal for the companies involved to start finding a way to decarbonize, especially when a carbon price or something else comes into the mix. And then we've put together our own little index within Jacobs to sort of track which countries really are the more progressive. And part of that discussion was around the number of announced projects for export as well as domestic use. And Australia is off the charts. I mean, we see a lot of that in the news already. There's 135 plus projects announced there. But Germany is probably second runner. It has close to 100 projects when we last checked. And then let's say the US is just emerging and starting to accelerate. There's a lot more activity there recently. So when you put all of this together with the legislative drivers and carbon prices and also the renewable resource in terms of the best solar or wind or hydropower as well, there's certain places on Earth that appear to have lots of things in place and are probably the more progressive and more likely to take the lead in the energy transition. Those places with the best renewable resources, that there's a bit of a green gold rush, I would say, underway at the moment, where you're getting companies rushing in to secure the best locations in terms of the land access, with a view to exporting from Chile or Western Australia. And then from an Asian perspective, we made this chart to really show the difference between the energy exporters and the energy importers, and highlighting some of the Asian countries on it. And I'd say for those wealthier countries in Northern Asia, that's the top tier, Japan, South Korea, and Singapore's in that bracket, I could say. They have an opportunity to create the technology that is integral to this new energy supply chain that's not limited in the same way as an oil and gas field is, if it's based on renewables, but it lasts forever. And so I think those countries realize the size of the prize, and they're trying to stake a claim early on those best territories, and encourage, it's like the Betamax VHS sort of battle between different technologies. It may not be the best, but some are getting a lot of promotion and support from government entities. So those first projects are starting to emerge now, and the supply chain is developing. Whereas the bottom part of this chart is really showing the countries with a lower GDP that are more rapidly developing, I'd say, that they have a real challenge. They can't really invest as much themselves. Their population is growing fast. So really it needs investment from outside. It's going to need those northern partners with their own technologies, perhaps, to develop the energy exports from those Southeast Asian countries. So I won't talk through all of these. There's a busy map, and so there's the next one, but there's many projects been announced in Asia. There's a lot more besides this, and also the Middle East on the next slide. But there's a lot of activity in the Middle East. It's probably easier to pick out where the more progressive countries are in this sense for hydrogen, and it's really Saudi Arabia and Oman and UAE. UAE is working on its hydrogen strategies at the moment. Saudi's already got one, I think, an outline one, and investing billions in it in terms of the NEOM. So you can start to see where the export projects will be, and that these countries are more hedging their bets as they export a lot of oil and gas already. So they see this as a hedge, I would say. If their export changes or people decarbonize their energy supplies, they're going to need the green alternatives. And you're seeing some of the lowest solar prices announced globally in the UAE and Saudi at the moment. So at the prices they're announcing in the headlines, they may not be the real prices, but even if they're close to those prices, it's already getting very competitive to produce the green alternative to blue hydrogen. We can skip this one. Yeah. Thank you. And then on to Singapore. I know Prof. Ho will know this chart and picture very well, but Singapore has set its targets and it's created what it's called its 4 switches. So they're going to rely on natural gas, and as they have to, they import natural gas to cover about 95% of its energy. They have domestic opportunities to produce energy, but it's quite limited. So it'll be solar, 1.2-ish gigawatts of solar. I think they've already done a few hundred megawatts. There may be opportunities to expand the waste to energy. Other than that, they really have to rely on imported energy. And that is either interconnections, if we go on to the next slide, or import of energy in some form. So the difficulty is that demands from the industry and the commerce here in Singapore is growing rapidly. So we do a lot of work on data centers, and there's practically a queue of data center companies wanting to develop more data centers in Singapore and expand what they've got. And they're really clamoring for that low carbon energy, as all of those big tech companies have made their own announcements around decarbonizing. So Singapore has to find a way to enable that low carbon energy. So it's either interconnections really from Indonesia or Malaysia, or pipelines if you can produce hydrogen over there, or it's seagoing freight and transport. But there's already politics around that and some nationalism around around the low carbon energy. So Malaysia is just, I think, banned. Maybe, I don't know if it's what exactly you call it, but they've just said they will not export green electrons over to Singapore from Peninsular Malaysia. So that already, you're seeing a bit of resource nationalism, which has changed the landscape. So I need to put a big red cross at the north of this for the green electrons. But Indonesia is still open for business right now. But if the pressure on those countries increases, you can see that being a risk, which really leaves the ocean-going transport of hydrogen and hydrogen carriers as an alternative. I think we can skip this one as well. Yeah. So that's really summarizing what I just said. And yeah, there's a number of competing technologies in hydrogen carriers. You could liquefy it. I won't talk through all the details, but liquefying hydrogen is still very expensive and isn't done on large scales really anywhere outside of NASA. There's a lot of gas handlers doing it at smaller scales, but the costs are prohibitive right now. There's liquid organic hydrogen carriers. There's quite a few different chemicals. You know, there's dozens and dozens of chemicals in that category. Methyl cyclohexane, or MCH, is probably the front runner for now, or there's another one in Europe which Hydrogenius is developing. The others are sort of earlier in the R&D life cycle or lower technology readiness level. But ammonia, which if I've got that next slide, I think ammonia is a more established supply chain. Yeah, so it's widely traded already. It's widely produced. It's obviously used for fertilizer, so that there will be a bit of pressure on ammonia use from that side. But I've borrowed these charts from the hydrogen strategy, and it's comparing the different the numbers of vessel movements you need, and the amount of storage you need for each of those carriers. LOHC has some advantages, so it's not as clear cut as that makes it look. You can crack MCH at lower temperatures, with lower pressures, so it's easier to get out the hydrogen at higher purity, and which makes it suitable for use of fuel cells. Whereas ammonia, they haven't quite cracked the technology problem yet. They're still working on it, so it's a bit challenging. But whereas if you're burning ammonia directly for combustion as a bunker fuel or in power plants, that's when it looks far more efficient overall. But for now, I'd say it's quite a close race, and MCH, which is the Spira technology from Chiyoda, that probably has a bit of a niche over the next few years, because it's the only one that can readily, is commercially available right now, that can be readily cracked to produce pure hydrogen. And then Japan is doubling down on ammonia at the moment. I've just put a few numbers in there from JERA, which is just one of the power companies in Japan. So that them and other companies are working on a trial for ammonia combustion in a coal power plant. IHI and others have worked on testing ammonia combustion in a CCGT already, a combined cycle gas turbine. They say that works okay, but I'd say most of the activity is around using the waste heat from CCGT to crack the ammonia, produce the hydrogen, and feed it into the turbine. So Japan, I'd say, is leading the way in a lot of the activity, investing a lot in this space, in hydrogen carriers generally. But it does feel like ammonia has some advantages when it comes for combustion, especially as a bunker fuel. And then I'll just touch briefly on carbon capture and the hubs. So personally, I believe that you need carbon capture to meet those net zero goals. Every scenario you run, you know, whether you're a fan of green or blue, I think you need them both, and it's not really helpful having this battle between the two that we're seeing in the media right now. There are questions around carbon capture in some parts of the world where maybe fugitive emissions are higher. But in many parts of the developed world, you know, that those fugitive emissions are 1% or less. So there was a paper recently that got a lot of headlines, and obviously not positive. But I think that life cycle analysis is important. It's just we need to be aware of the criticism there that's emerging. But I'd say more than this, the main problem is how do you make it economic, or how do you incentivize people to trade CO2 around? So we're seeing lots of talk and activity around carbon capture hubs, but yeah, really that it comes down to the economics and how do you create a system where people are incentivized to move it from A to B. I think that that's what will probably happen here one day with the carbon price, but that needs to happen cross borders. And when we talk about that two-tier Asia, it has to be about collaboration, and those people who would theoretically take the CO2 and store it in their depleted gas fields, they need to benefit in some way. So I think it's reaching more of a political, geopolitical level about the benefits to the regional partners. I'll leave it there. Actually, that's just a summary map that's probably too busy to run through of hydrogen projects we've worked on in the last 3 years. So yeah, thank you for your time. Okay.
Thank you, Andrew, for the very interesting presentation. And now we are going back online to Norway. And I'd like to invite Dr. Federico Ustonin, Team Hydrogen at Norwegian University of Science and Technology, to give a presentation on hydrogen research at NTNU and SINTEF. Dr. Federico, can you hear me?
Yes, I can hear you. Can you hear me?
Yes, we can hear you well, and your shared screen is already up. You have 10 minutes, so please go ahead. Thank you.
Okay, thank you. Thank you for your introduction, and thank you for inviting me as a speaker today. Today, as you said, I will talk about the hydrogen research at my university, the Norwegian University of Science and Technology, and also a bit about SINTEF. So, first of all, I am postdoc at NTNU University, and I'm working on hydrogen safety. I'm also a member of the NTNU Energy Team Hydrogen that you mentioned. And this, I will come back later to this NTNU Team Hydrogen, but I just want to say that it is probably the largest hydrogen R&D cluster in Scandinavia, which gathered together many professors and researchers in NTNU that works on hydrogen. I would like to introduce very briefly my university. So it's a technical university, but there are also many other faculties on social sciences, medicine, and health sciences, and so on. The headquarters of the university is in Trondheim, where I'm seated now, but we also have 2 other campuses in Gjøvik and Ålesund, which are 2 other small Norwegian cities. And NTNU has also 1 office in Brussels and in Tokyo as well. Just a few key figures. We have a total of 8 faculties, 55 departments, 9,000 employees, and more than 42,000 students. And in 2020, there were up to 400 doctoral degrees and very large owned and rented facilities, so different campuses, as I already said. So moving back to the main topic of today, which was already mentioned about global warming and the objective to keep the temperature increase below the 2 Celsius degrees. You already said that hydrogen can be one of the main solutions. Norway can be a supplier of clean hydrogen, both blue or green, as well as hydrogen technology. But still, there is a large knowledge gap. I work mainly on hydrogen safety, so I can say that there is a knowledge gap in hydrogen safety, as well as in the energy system, hydrogen energy systems. And this, of course, represents a bottleneck for the hydrogen deployment. The good thing is that in the last couple of years, the interest in hydrogen increased a lot. Even before the pandemic, the interest in hydrogen was increasing, as was mentioned by one of the reports of the International Energy Agency. But after the pandemic, we had an exponential increase in hydrogen interest and investment, because in this year, many investment plans were signed. And this also confirmed what was said about a speaker earlier today, that many technologies are ready, but we also need the political choice, the political confirmation to implement these technologies. To talk to talk about the hydrogen properties, when we compare it with other fuels, many of you might know the properties of hydrogen, why it differs from other conventional fuels. But I would like to show you this table, this comparison table today, just to highlight that, of course, hydrogen has many pros and also many cons, as the other fuels. So we want to use it because it has a high gravimetric energy density. It is clean and it it's potentially renewable, is not toxic, and from a safety perspective, it's good that its flame is it burns very fast. Because it means that a fire will last less than for other fuels. We have a density issue, as you mentioned before. For example, many companies and countries are planning to transport hydrogen through ammonia or other carriers. But also the density, it's a drawback, as it can be seen as a pro, because from a safety perspective, it's so light that if we have a release of hydrogen, at standard conditions, it will just rise toward the atmosphere. Then, of course, we have other drawbacks from a safety perspective, especially the minimum ignition energy is quite low, compared to other conventional fuels. Then its flame is not visible, which is bad for a safety perspective, but it's also good as well because the radiation will be low compared to other flames. And then it's difficult to detect. So the conclusion of that table is that hydrogen has many peculiar properties, and it must be handled in a different way than other fuels. As many of you may know, there was an explosion in Norway 2 years ago in June, close to the capital, Oslo, in Sandvika. One of the hydrogen refueling stations, one of the few in Norway, exploded because there was a leak from one of the high-pressure tanks. And of course, this has huge consequences on not only on the damage of the facility. Fortunately, there were no fatalities, but the consequence was that the hydrogen supplier closed all the stations in the hydrogen refueling station in Norway. Even the hydrogen cars, the selling of hydrogen cars in Norway was stopped for a period. And then we ask if was it necessary or not, because if this will happen for conventional fuels, of course, the production and the selling of gasoline or diesel will not stop because it's an established technology. But in case of hydrogen for new applications, it's an emerging technology, and emerging risk might arise, and for precaution, everything was stopped. So to avoid this, we are focusing on our research on safety, but in our NTNU hydrogen team, we also focus on many different aspects. So as I said before, this team was created by Professor Bruno Poller at NTNU, and the idea was to gather together many different expertise. So all the researchers working on hydrogen. And as you can see in this list here, these are all the different topics that are studied about hydrogen. So in our group, we studied the materials, the membranes, all the material degradation mechanisms such as hydrogen embrittlement, the hydrogen storage, the safety, and so on. So it's becoming to becoming to be a very large group. There are up to 56 members in this group, a very large number of publications, more than 5,000, and a very large number of projects. And as you can see from the map here below, the network is quite large because thanks to the network of the researchers which are members of the group. Then, in addition, we have many different laboratories, and a few of these in NTNU are dedicated to hydrogen, in particular when we study the materials, and also in collaboration with SINTEF and IFE, which is the Institute for Energy Technology. It was established the Norwegian Fuel Cell and Hydrogen Center, which is one of the largest in Scandinavia. So talking about the collaboration between NTNU and SINTEF, SINTEF was founded in the 50s. It was a spin-off of the former NTNU university. And of course, there are still today many collaboration in a very large number of projects, and also in hydrogen. So I will not talk about the SINTEF today. I'm not a SINTEF employee, but I can say that the collaboration is very tight. I am also personally collaborating with many SINTEF researchers. We also work in the same facilities, and also we apply for funding in the same consortium. So there are really plenty of projects that SINTEF and TNU are conducting together. I cannot present all of them today, but I just want to give you a glance of one, which is called the SHIFT project. SHIFT stands for Safe Hydrogen Fuel Handling and Use for Efficient Implementation. Very long title, that's why we use the acronym SHIFT. And this is a project focused on safety. The aim of the project is to analyze both societal and technical barriers for hydrogen implementation. As you can see in this picture, we focused on a jet fire for gaseous hydrogen leakage from high pressure tanks, and also on physical explosion for liquid hydrogen. So if an explosion may occur after a release of liquid hydrogen, both from the catastrophic rupture of a tank or when liquid hydrogen is spilled on water. So this is a very cutting-edge research for hydrogen, especially for liquid hydrogen. And it's very interesting that in this project we are also analyzing the societal barriers. So all the concern from industries as well from the public society. And this is a knowledge building project for industries. The duration is 4 years, and actually we are going towards the end of the project since it started already in 2018. It's mainly funded by the Norwegian Research Councils, as well as many different private and public partners. There are also international partners such as Shell and Air Liquide, Ariane Group. So it's very interesting project from a safety perspective. And in this project, we conducted experiments as well as the modeling of the phenomena that I mentioned before. The good news is that the SHIFT-2 project, which is the continuation of this project, was already funded by the Norwegian Research Council, and it will kick off in a few months. If you are interested in more details of this project, you have the QR code. And that was all from my side. I thank you very much for your attention.
Thank you very much for your presentation. And before I move on to the last speaker, I'd like to check with Lars whether you are online. And if you are, may I suggest you can perhaps give a very quick, say, 3-minute summary of where you left off with or without slides is up to you, but it will be good if you could finish your presentation. Lars, can you hear us?
Yeah.
Yeah, so I'm going to let the next speaker speak first, and then after that, we'll come back to you. Is that okay?
Yeah.
Yeah,
Perfect.
okay. So please stand by in the meantime. So now, next, I'd like to invite Ms. Anu Fredrickson, the Executive Director for Arctic Frontiers, to speak. And she's going to talk about the Arctic Frontiers 2022. I think some of you may already know Singapore is a very active party to the Arctic Frontiers. Mr. Sam Tan has been going there quite regularly, and it's a very important platform for Singapore because first, it shows our commitment to the Arctic agenda. Second, it gives us the opportunity to showcase Singapore science and tech developments as well to the Arctic community. So I will let Ms. Fredrickson take over now. You have 10 minutes, so please go ahead. Thank you.
Thank you so much for the kind introduction, and thank you for having me. Excellencies, ladies and gentlemen, dear friends of the Arctic. Echoing Ambassador Eivind Holme earlier this day, what happens in the Arctic does not stay in the Arctic. This sentence we hear time and again, even to the extent that it is about to lose its novelty. I would like to echo what Special Envoy Sam Tan said in his keynote and turn this notion upside down, if you wish, because we firmly believe that the connections between the Arctic and the global are not a one-way street. This is probably best visible in the business sector, which has also been discussed here today. Arctic is very attractive to many of the non-Arctic stakeholders because of its strategic location, access to resources, and so on. But the Arctic is equally dependent on having access to the global network and to the global value chains. These interconnections between the Arctic and the global are also visible in the scientific field, because within science, every contribution matters. We still have a scarce understanding of the Arctic ecosystems, and we have a scarce understanding of the known and unknown unknowns. Therefore, other countries' contributions through various international mechanisms, whether that is intellectual or financial contributions, will benefit the entire global community who wants to better understand what's going on in the Arctic. Climate change poses us with a challenge which is first visible in the Arctic. This is a challenge that is jointly identified by the global community. And as such, it should encourage us to come together and cooperate, contribute to technology development, innovation, solutions, such as we have discussed today. But these discussions do not take place in a vacuum. We need agenda setters to bring us together and to lift these topics up. And this is where I believe that Arctic Frontiers comes into the pictures. Because Arctic Frontiers is an arena for global discussions about the Arctic. It is an arena which brings together the global community interested in the region, and an arena which facilitates work on these common challenges. Arctic Frontiers is something that is founded in a partnership. Within the Arctic Frontiers partnership group, we have about 30 leading institutions, ministries, and businesses working within Arctic issues and in the Arctic. And it gives our team and our partners a great pleasure to be able to welcome businesses and policymakers, academia, researchers, local community representatives, and indigenous peoples back to Tromsø at the end of January 2022. This will be the 16th consecutive Arctic Frontiers conference. When our team was planning the theme for the 2022 conference, our starting point was in the global developments. We looked at what's going on and how these developments will have an impact on the Arctic. Therefore, we landed on the title Pathways. For us, Pathways reflects on the choices that the Arctic is facing when addressing pressing global challenges. We try to seek pathways to economic development, sustainability, climate action, security and stability, and respect for science in a world where science is not trusted by all. We are in the midst of a transition, a societal transition, policy transition, business transition, and also a transition to a greener economy. And therefore, the 2022 Arctic Frontiers will focus on opportunities within blue economy and space, transition within finance markets, and one of the transitions with probably the highest significance for us all, energy transition. As has been highlighted by numerous speakers earlier today, we have a growing need for energy with the growing global population, but at the same time, we want to become carbon neutral. We are living in a time where we are witnessing a looming energy crisis on a global level. At the same time, it is more lucrative to continue to produce fossil fuels and coal. We heard that fossil fuels will continue to dominate the energy mix, at least in parts of the world, in the years to come. At the same time, the International Energy Agency has embraced the notion that the share of fossil fuel in the global energy mix has to drop from current 80% to a little bit over 20% in just 30 years' time. When we strive to achieve these goals, we believe that Arctic can be a solution to many of the challenges that we are facing. It is a region with an abundance of energy, renewables and fossil. It's a region which has mineral reserves and stable conditions. And as the previous speakers today have highlighted, with technological development, we will even be able to gain access to stranded assets, which previously have not been available due to lack of infrastructure. We believe that this transition to new energy forms can actually be an opportunity to broaden businesses in the Arctic, but it is also an opportunity to broaden our cooperation with stakeholders outside the region. But looking at all of this from an Arctic and local perspective, there are difficult questions that remain to be answered. One of them is whether we can avoid the Arctic squeeze. Consequences for climate change call for further development of renewables and extraction of natural resources, which in turn creates additional press on land and on people. We are already witnessing local discussions about some pushbacks. The Not in My Backyard movement is also gaining ground in the Arctic, and we hear our Sami friends raise their concerns related to green colonialism. These are all issues that we will have to solve together, and therefore the Arctic Frontiers will provide an arena for these challenging discussions, and also an arena for Arctic to global collaboration. We believe that the Arctic can be an incubator, because many of the challenges that the Arctic faces are also applicable on the global level. So let the Arctic be our incubator to develop the region, but to serve the global good. We look very much forward to welcoming you to Tromsø on January 31st, 2022. Thank you.
Thank you very much for the presentation. And I think the earlier speakers have been focused very much on hydrogen, but it's good that you have expanded the context to remind us why we need hydrogen, why we need to examine hydrogen as another source of fuel because of climate change issues that we are facing today. So now, Lars, are you there?
Yeah.
Okay, so I suggest 3 minutes for you to give your presentation, a quick summary. Yeah, you can go ahead.
All right.
Fingers crossed this time.
Yeah. So what I have presented to you is a project that we are running at the moment. It's a world-scale production facility for ammonia and clean ammonia, blue ammonia. The overall system that we have today in Norwegian part, gas available, hydrocarbon gas that consists of carbon and hydrogen. We developed this plant to utilize that gas to produce hydrogen and then ammonia. And the CO2, 99% of that CO2 that is within the process flow is extracted. It's transported by special developed carriers and then injected into a reservoir that we are currently have applied for. The ammonia, that is 1 million ton per year or 200,000 ton hydrogen that it consists of, is transported and distributed, and is also part of our project because all these carriers need to be run and fueled with ammonia to be sustainable. The company, we are developing also the company. I will not say so much about it. We have made some decisions why ammonia is good because of transportation cost and also energy content on a certain volume and maturity on distribution. Very high focus on the standard because we are in the north part of Norway, sensitive areas, and very much focused on the everything that goes into the use of chemicals and emissions. I presented the area, the site location that we are developing at the moment. The electricity is renewable that we need, so it's a limited amount of electricity that we need for this plant because we use the energy from the hydrogen that we produce, so we are able to burn hydrogen to provide the heat that we need for all the processes. We are currently developing the first train, and we are aiming for 3 trains, so increasing the capacity with 3, so from 1 million to 3 million tons per year. The schedule, we are in the concept phase and doing studies at the moment for the system and the whole plant and everything you have seen from the carriers to the application, the reservoir, the shipping, the distribution, everything is done at the moment. We are entering then a next phase next year that we are detailing out the concept, and there will be a decision point for project execution and start operation 2025. This is done together with our partners and also the vendors that we rely on. I will not say too much about it, but we get gas in, we use the energy from the hydrogen, and out we get hydrogen and CO2. We extract the CO2, then the hydrogen is converted to ammonia by adding nitrogen from the air, and also oxygen from the air is used to the firing. This is a part of the project, and also remote control and automation, and this is a high capacity reservoir that we have developed and applied for a license, so we're able to store a lot of CO2 currently. I think that's it in 4 minutes, sorry. If you heard it.
Yeah, thank you very much, Lars. Okay, so the 6 presenters have given their presentations, and we have until 5:30. I thought we can perhaps take 1 or 2 questions. But before that, I thought I'd just give a very quick summary based on what the presenters have said. And I've come up with 4 basic points, which is first, I think in terms of the development of the hydrogen, people or companies and governments are still identifying production opportunities. Next, there are still technical and economic challenges to overcome. Third, we still need to consider the practical safety, social, and regulatory issues. Fourth, we also need to identify other developments that would help develop hydrogen's role as a final energy carrier, as a fuel, and as a feedstock. So I think today's presentations have been quite insightful to give us a sense of the state of hydrogen development in the Arctic and in Southeast Asia. Obviously, this is just the beginning, and we need more conversations like this. And the important takeaway point for me is that there is still a lot of opportunities for cooperation and collaboration, particularly between the researchers and the businesses in the Arctic and in the tropics, right? And Singapore is a very good base for that. So I will stop here. Perhaps we can take one or two questions or comments if there are any. Yeah. No? You can just stay at your table and use the mic if you wish.
Maybe I can try one.
Yeah, sure.
So assuming that hydrogen or ammonia or whatever forms that hydrogen is transported will be an important part of the energy infrastructure in this region. I'm thinking about the aspect of transportation, and I'm looking at Path here, which is from Höeg LNG, expert of transporting cryogenic gases. What are the challenges really of either ammonia transport or hydrogen transport? Is it feasibly possible, technological-wise and economic-wise, to build ships? And if it is, would Singapore yards have another opportunity of developing this kind of technologies? What's your view on that, being in this business? You can use the microphone there. Maybe take this one, maybe.
Hi. Yeah, thanks. I wasn't expecting this question. but since you asked...
Is it working, the sound?
Hello.
Oh, there you go.
Yeah. With this mask, it's very challenging to figure out like how far do you need to go. So yeah, this is quite an interesting question, and that's where we are in LNG. So Höeg LNG, we do FSRUs, so we are the market leaders in FSRUs. We have the biggest fleet on water. Now for us, as well as the industries or the whole energy industry is moving towards newer fuels, and ammonia and hydrogen keeps coming back again and again in our discussions. So we are looking at can the terminals, or how the terminals of the future will look like. So we look at ammonia and hydrogen from two perspectives. One is the world's fuel. That means we are just the terminal owners and operators. And second, the marine fuel. So marine fuel is probably relatively easier to handle. And there are a lot of discussions probably picked up on ammonia and ammonia bunkering and so on and so forth. Hydrogen is still a bit challenging. But when you start talking about large-scale hydrogen transportation from, say, countries like Australia, typical route that this region is looking at, sending hydrogen from Australia to Japan, Korea. That's first thing that comes to everybody's mind. As you picked up, Andrew, okay, those countries in the box on the right-hand side, so who can pay for it? The challenge is, if you're just looking at compressed hydrogen or liquid hydrogen, the technology is not there yet. There are a few factors. First is the technology itself in terms of the materials for storing liquid or compressed hydrogen. And then when we talk about long distance transportation of hydrogen molecule in hydrogen form, then concepts like boil off gas, what do you do with that? How much volumes or can you actually transfer? So transporting 5,000 cubic meter of hydrogen would be as big as nearly as big as a modern LNG carrier, just because the volume of hydrogen is so big. So there are practical challenges, but the industry is working towards using organic compounds or metal compounds and ammonia for that matter, for hydrogen for carrying hydrogen across longer distances. Those are more feasible, and that's where we see the industry is moving. Pure hydrogen, very challenging right now. I don't know if I answered your question, Per Christer.
No, thank you. I think that was a good answer. There is still a way to go.
Yeah.
And I think again, maybe the arts or the maritime industry here in Singapore has an opportunity to grab in this space in cooperation with Norway, I believe.
Definitely, definitely.
I think I see.
Yes.
Simon is
Simon,
nodding.
I see
Simon
you're
from
nodding your
Sembcorp is
head.
nodding as
Yeah.
well. So yeah.
Would you like to say something?
Okay, thanks. My name is Simon. I come from Sembcorp Marine. I think for the future fuel, there's a lot of development going on now for the whole value chain. Each of the value chain partners are trying to validate whether is it possible to either produce it, store it, transport, and also ultimately use it. So at this moment, the clarity about the way forward, which fuel, both on the land for utility purposes and also for marine times, are still not exactly that clear yet at this moment. But I think, but if you compare to say 5 or 10 years ago, where we started discuss about decarbonization, less people talk about it, and also it's less clear which way to go. Today, I think there are more consensus. So, say for example, for maritime decarbonizations, we look at for harbor, we are using electrification as one immediate solution. And the electrification can be achieved, decarbonization, if the on-land grid are green. Okay, so that is a low-lying fruits, which I think Singapore Maritime Port has been driving this direction now. For the long-haul shipping internationally across ocean, then we are looking at transportable fuel. Transportable fuel today, as an interim, we use LNG, which is this gentleman expertise area, widely deployed now, and I think this fuel will be around for a while more. Will be a while more because it's the most ready, safe, and also the logistic chain, supply chain are more established. So what next fuel need to make it viable, need to replicate what LNG has been achieving over the last 20 years. So in our view, the ammonia offer that opportunity because technologically it's more ready. We are already using LPG tanker. They are already production plant using LNG as a feedstock. So those are much more ready than hydrogen. Hydrogen, I think I hear from many speakers here present as really more potential for a net zero outcome. Okay, so a lot of investment will have to go in to ultimately make hydrogen safe, cost economically, and also make economic sense for all of us as we go forward. A lot more collective action from all the stakeholders are required in this area. Yep. So that's my take on the future fuel. Thank you.
Thank you very much. Do we still have time, or shall we just end it now? Okay, so we are ending this session now. Please join me in thanking the presenters for this session. And thank you for your patience, and we apologize for the slight technical hiccups that we experienced. So now I'll hand the floor back to Per Christer.
Thank you. Very good. Sorry for all the technical hiccups. I think it's new for many of us to actually do something physical after about 2 years of all virtual events. But anyway, so thank you very much, Chris. Excellent moderation of this first panel. We move over to the second panel. I just want to share a few reflections on Singapore-Norway research and academic cooperation, since I have the chance here in general. So this Science Week is the anchor event for research and academic collaboration between our two countries, universities and institutions. We've had 2 years of quite challenging conditions when it comes to mobility, student exchange, faculty mobility, arranging physical meetings, which is so important to build relationships. But we have confirmed that there are significant interest for continued collaboration in many areas. We have strengthened and confirmed the traditional areas where we have had collaboration, the maritime sector, in the energy sector. But over the last year, we also seen increase in interest for new areas like medtech and digital health, in circular economy, including solutions for waste management and food production, especially in the aquaculture sector, and also on other aspects as on decarbonization, including now hydrogen, or we're talking about now, and carbon capture utilization and storage. We've seen a few new institutions coming on board over the last year, including Singapore Institute of Technology and James Cook University on the aquaculture side. They have a subsidiary here in Singapore. And also from the Norwegian side, we see research institutions like Nofima, specializing in the food value chain, and Norse from the Norwegian side. And specifically Norge, and that Norse then moves us over to the new panel, focusing on cooperation with Earth Observatory of Singapore, which resides at the Nanyang Technological University, on climate change modeling and predictions, especially related now to sea level rise. And that leads us over to the last panel, the session of today. I'll hand it over to Marianne Franco of the Energy Studies Institute to moderate this session. Marianne.
Yeah. Thank you, Perkister. So we come to the last, but definitely not the least session for our workshop today. So the topic of our session would be on climate change predictions connecting the Arctic and Singapore. So we would have two presentations for this session. The first one would be on climate research at Norwegian Research Center, that would be co-presented by Dr. Christine Malevik, Chief Executive Director of Norwegian Research Center, and Dr. Christine Richter, also from our Norwegian Research Center. So, Dr. Christine?
Okay. Yeah, this looks
okay.
Better. Yeah, thank you.
We have defined 4 area.
You're breaking up.
Action. The climate also sustain. And of course, our goal to reduce CO2 emissions. A large group focusing on also the oil and gas, but mostly now focusing on renewable energy. Technology, developing enabling technology, and of course in close collaboration with industry and the user. So it's really user-oriented, together with all the other areas that we have. We have a department on health and health research and health-related services, meaning that we have to really make sure that we combine the social sciences and the health area. And then we have a group on social sciences focusing on, for instance, democracy, inequality, could be social sciences, and also measuring and looking at the effects of the large transformations happening in the world today and also in Norway. And this group really focuses on effects of various transitions. And then we have a department or a group working on environment issues. And here we have bioeconomy is one area, becoming one big area, aquaculture, and not the least circular economy. So this group really works on the environmental issues. And then finally, we have a very solid and robust group on climate and climate research. This group really combines the basic research with the applied research and how we can best adapt to this change. And of course, in this setting, this is the most relevant group. This group has a mission towards a climate-informed, resilient, and environmentally sustainable society. So this group really focuses on the climate changes, and as I mentioned, that focusing on using the basic research and combined with the applied research. And of course, there's several areas that need to be interdisciplinary, but the climate research group is definitely one of the strong groups in NORS. Several areas are included in this group, and the main challenges focused here is the climate change, of course, extreme weather, and the climate adaptation. So some of the priority areas, you will hear one of the areas afterwards, and of course climate predictions has become one very important area, both season and decades. The carbon observational network, both ocean and land, and acidification, and not the least to develop the next generation climate models. Now, I would like to give the word to Kristin Richter. Future sea level rise is one of the biggest challenges for Singapore as well as for Norway, with their densely populated coastal regions. It is a complex problem with many aspects where both interdisciplinary and international collaboration is crucial to understand this challenge. And now Dr. Kristin Richter will present the sea level research that is conducted at NORS and that may complement sea level research in Singapore. The word is yours, Kristin.
Thank you, Kristin. I think you must have to stop sharing, so yes, thank you. Can you see my presentation?
Yes.
Wonderful, thank you. Yeah, thanks a lot for inviting me. So I will give a short overview, or more like a flavor, over what we do with respect to sea level change in NOS. Yeah. So we are a rather small group still, but we are really growing fast and we cover a broad range of expertise. And just to reinforce what Kristin just said, so this is a figure or a photo taken, about a year ago or winter last year in Bergen in Norway. And what you can see is actually that the old harbor in Bergen is flooded. And at this point in time, we were just 1 centimeter short of beating the highest sea level ever measured in Bergen, and that happened actually 30 years ago. And both of those events 30 years ago and last year qualified as a once in a 1,000-year event, actually. So clearly something is changing, and statistics need to be revisited. And this is also a topic where we hope to learn from our colleagues in Singapore that we already collaborate with, because they really do have a strong expertise in statistics and extreme events. But what is it we do? So how can we contribute? So I'm going through a few examples of what we do here at NOS. So this figure shows the change in sea level over a 10-year period. So I really want to emphasize this is just the difference between 2 consecutive 5-year periods. So it's very different from the long-term mean. But what you can see here is that there are coherent patches of variability. So you can see areas of strong sea level rise and areas where sea level is falling over this short period of time. And this is actually governed by changes in ocean heat content. So changes in temperature of the ocean. So you can see the observed sea level very much follows the pattern of observed changes in ocean heat content. And in a project called TikTok, we investigate actually what drives these regional ocean temperature changes. And these changes consist of two contributions. So we do have the redistributed heat that is largely due to circulation changes, and we have the added heat that is the direct response to increased radiative forcing. And you can see this observed pattern is very much driven by the redistributed heat. In the long term, sea level will be driven by the added heat, so by this more uniform pattern in the lower right corner. But on short time periods of 10 years or so, this redistributed heat is really very important because it can exacerbate or dampen the long-term change in sea level. And this can also impact, for example, the magnitude of extreme events over shorter periods of time. So it is important to understand how these patterns are generated as well. It is also important to compare these observed characteristics with climate models. And this is an example from our region. So this is sea level change observed over a 20-year period in the northern North Atlantic. So you can see Norway here. And you can also see coherent patches of variability. And here we used a slightly different approach using an ensemble of climate models to separate this pattern into a forced signal and into internal variability. So this roughly corresponds to the added heat here and to redistributed heat below. And when you combine, so this is observations, and in the middle you can see models. And if you combine these two model signals, you get the simulated signal over this period of time. And you can see it's actually, it agrees rather well with what has been observed. And this is a very strong result for climate models, actually. And by really identifying the climate models that do a good job at this, we can also try and reduce uncertainties in future regional sea level projections. And this will also be important for Singapore. So this is the ocean. However, the largest contribution to future sea level rise will come from the ice sheets. And at North, we have a variety of activities related to changes in the ice sheets, both in Antarctica and in Greenland. And I will start with an example from Antarctica. At North, my colleague Petra Langebroek and Svein Østerhus, they lead a large EU project called TIPEX, so Tipping Points in Antarctic Climate Components. And there they focus on the ice shelves. So the ice shelves are these floating ice tongues that surround large parts of Antarctica. And recently it has been observed that the water below these ice shelves has warmed. And this could actually lead to melting from the ice shelves from below. So it is important to know that the ice shelves, they really stabilize the bigger ice sheet of Antarctica. And when these ice shelves become unstable, this support vanishes or it gets smaller. And we do have an increased mass loss from the Antarctic ice sheet. So in this project, we look at two tipping points. One is the tipping point in really the ocean. So we try to investigate when does the ocean change from a cold state into a warm state that would actually facilitate this melting of the ice shelf. And we also look at tipping points in the Antarctic ice sheet. So what happens actually when these ice shelves disappear? What does that mean for the Antarctic ice sheet? How much ice can be lost and how fast? So this is not directly a projection, but it's more a high-end sea level scenario, which is really also important for stakeholders with low risk tolerance. We also do actual projections, and here I would like to show an example from Greenland. So this is a result from the Ice Sheet Intercomparison Project, ISMIP6, which my colleague Heiko Gölzer is leading. And this is really the first time that ice sheet projections are organized or coordinated systematically across the entire ice sheet modeling community. So this is really something new. And results were already included in the last IPCC report, and you can see some examples here. So one result was, for example, that the contribution from Greenland to sea level rise can be between 30 centimeters and a bit short of a meter in, not a meter, 10 centimeters. So it's either 9 millimeters, 9 centimeters, or 3 centimeters by the end of the century, depending really on the emission scenario. So that was one result from the last IPCC report. And the approach here really is to wait for the international climate community to run their climate models, take the output from the models, and then force ice sheet models. However, the next step really in integrated sea level projections is to couple or to include interactive ice sheet models into the climate models. And this is an activity that is underway here at partly also at NOS, to include an interactive ice sheet model into the Norwegian Earth System model. And this will really allow for and for also considering feedbacks between ice sheets and climate. And this is really exciting, an exciting result. Lastly, I'd like to also briefly say something about communication, because the science we do, it's really all good and well, but we also need to know, what do our stakeholders want? What do they need? Is the science we are doing actually useful for them? What do they need for their adaptation? So we do a lot of outreach to the general public. We go to bars, for example, and give presentations. We go to schools. So we have a wonderful project where we go to a school and explain about tipping points and sea level rise. Have the students actually produce art based on what we told them. And this art is actually being really shown at a conference in January, at the climate conference here in Norway in January, where really high political stakeholders will also be present. So this is really nice. We do podcasts and all kinds of things, but we also contribute to, for example, the National Report on Sea Level Rise, where we work a bit closer with stakeholders. We participate in international knowledge hubs on sea level rise, and we really try to also work with local stakeholders, like, for example, the city of Bergen. So this is really important, and different countries have different challenges with communication, and here I really see that we can also benefit from experience from our partners in Singapore, and hopefully vice versa. Yes, and this is what I wanted to say. Thank you very much.
Thank you very much, Dr. Christine Balvik and Dr. Christine Richter, for a very timely presentation with the COP26 negotiations. Our next speaker would be Professor Ben Horton, Director of Air Observatory of Singapore, Nanyang Technological University. His topic was on climate change in the Arctic, sea level rise in Singapore.
Is this how the slides look? It looks like they've been altered.
I don't know, if you try the next slide.
Let's have a look. Maybe it'll look okay. Okay, good evening everyone, or good afternoon. I'm Ben Horton. Is the microphone working? Can everyone hear me okay? Okay, so good afternoon, good evening everyone. My name is Ben Horton. I'm the Director of the Earth Observatory of Singapore. It's a great honour to talk in front of you today. It's a great honour, always a pleasure to listen to Kristen talk. She really is one of the leading stars in climate and sea level science, and we have a joint project together as part of the National Sea Level Programme here in Singapore to use the advancements that the Norse group have to add into the knowledge gaps that Singapore has regarding sea level rise. So I'm Director of the Earth Observatory of Singapore. This is a research centre of excellence. We have around 150 staff who are looking at problems to do with climate change and other geo-hazards in Southeast Asia. I'm a climate scientist myself. I've been studying this topic for 25 years. I was an author on the Intergovernmental Panel on Climate Change's 5th assessment report, and I was a review editor on the report that came out in September. And I'm going to go through just some of the brief details of it regarding sea level rise. I think it is very timely that I give a presentation such as this because we've been hearing over the last couple of days about COP26 and the commitments that different governments may or may not make. Well, without the science, you don't understand the severity of the potential impacts on climate change. Every single person, community, business leader and government needs to understand the urgencies and that you shouldn't need to do this. You should want to do this, because if we don't do anything about climate change, if we don't meet the Paris Agreement, existential threats to island nations such as Singapore are an existential reality, and that's what I'm going to try and show you today. So something, first of all, about the IPCC process. So the Intergovernmental Panel on Climate Change meets every 6 to 8 years to basically produce reports on the state of the climate. So the sixth assessment report had a team of around 230 authors. Importantly, they're from 65 different countries, so every continent on the panel is represented. The other interesting aspect is that for the sixth assessment report, 30% of them were new to the IPCC process. So we got a lot of early career scientists really contributing the state of the art. Now, the IPCC does not do science itself. Our charge is to review the state of the climate based upon peer-reviewed publications. So we reviewed 14,000 publications to produce our report. Our report is then itself peer-reviewed, but our peer reviews are not just other scientists outside the IPCC, but they are members of the public, industry, business. In total, we had 78,000 review comments, and as a review editor, my task was to make sure that every single one of those were addressed. A colossal activity, which I'd also like to note, you're paid $0. One of the things that I find incredibly annoying is that they say that climate scientists line their pockets with gold. Well, if I could have just got $10 for each one of those comments for my time, then maybe I would agree to that, but that isn't true. Once we'd finished our scientific draft, it's then produced as a governmental draft, and was given to a variety of countries. We had 46 different ones commenting on that. We had to address those comments before it was distributed in September. So the IPCC, as I said, there were 230 scientists, but really when it gets down to it, it's a relatively small group that looks at different aspects of climate. So I was part of Chapter 9, which was to review the state of the climate in the ocean and the cryosphere. Cryosphere means the ice on our planet, and then come up with potentially the most important statements regarding climate change. Certainly for Singapore, what are the projections of sea level? So the IPCC has a variety of sort of take-home messages regarding climate. And it was very pleasing to me that a variety of these take-home messages for sea level were based upon science that had been produced by the Earth Observatory of Singapore. I'm just going to highlight a few of them. So on this particular graphic, we're looking at a statement that says that global mean sea level rise is faster since 1900 than anything over the previous 3,000 years. That's an incredibly important statement. That shows that we're living in a very unusual time. And here's a graphic. It's from one of my graduate students' papers. It looks at rates of sea level change along the y-axis and century-scale bins along the x-axis. And this data is for the US Atlantic coast, showing that in the 20th century, the rates were around 3 millimeters per year, and for the preceding 2,000 years, they were at around 1 millimeter per year. Another take-home point is that Is the rate of sea level change, is it accelerating? Well, the IPCC concluded, based upon observations of data, that the rate was around 1.3 millimeters between a time period of 1901 and 1971, before nearly tripling in rate to around 3.7 from 2006 to 2018. And we have a publication that we produced at EOS where we reviewed all the other published literature calculating rates of global mean sea level, either derived from tide gauges or satellites. And then we subdivided it into the red, what were the rates in the 20th century, and the blue, what are the rates in the 21st century. And you can clearly see that irrespective of the author, irrespective of the data source and its associated uncertainty, there's a clear increase in rate from the 20th to the 21st century. And then finally, we come on to the projections. So the projections for the 6th assessment report have to be put into context from previous studies. So this is a graph from the IPCC, shows that the AR6 are compared to what's called the Schrock report, which was a special report on oceans and the cryosphere by the IPCC in 2019. The predecessor to AR6, AR5, which was published in 2013, and then some benchmark publications, and it was very pleasing that this includes something that EOS did a couple of years ago, or 1 year or so ago, looking at projections from 2100 and 2300. Now, Kristen sort of illustrated the details of climate change, because climate change science is complex, and I want to just go through with you some of the processes which enable us to understand how sea level is going to be projected into the future. So sea level is driven by a variety of global, regional, and local processes. All those processes that we have to understand their spatial and temporal fingerprint are shown on this schematic, but I'm only just going to highlight a few of them. So globally, there are two major contributors to sea level rise. On the bottom right is an animation of the volume contribution. So this is something that Kristen described. If you increase atmospheric temperatures, it's transferred into our oceans. When you increase ocean temperatures, they thermally expand, occupy a greater volume, and sea level goes up. On the top right is the mass contribution. So if you melt land-based ice, not sea ice, land-based ice, which is found in terms of glaciers, ice caps, and ice sheets, it is transferred into our ocean basins and sea level goes up. Now, in the 20th century, the dominant contributor was ocean volume, 50% or so of the sea level rise that we have observed. But worryingly, in the 21st century, it is our ice sheets that are contributing. Approximately 40% now comes from Greenland and Antarctica. And the worry about this is just how much water they contain within them. The Greenland ice sheet contains within it enough water to rise global sea levels by about 7 meters. But it is Antarctica that the community is petrified of, and I mean petrified of, because Antarctica is colossal. It's 20,000 times the surface area of Singapore. It's 2 to 3 kilometers thick, and it has enough water within it to raise global sea levels by 65 meters. Now, you only need to melt a small percentage of that ice sheet to catastrophically inundate the whole of the globe. Regionally. Now, the IPCC, for the first time in the 6th assessment report, gets down to regional projections of sea level, which I'm going to show you in a few slides. Now, there are two dominant regional contributors. The first one, on the top right, is a process known as glacio-isostatic adjustment. It's the dominant cause of spatial variability of sea level in the northern hemisphere. because there were regions that were underneath extinct ice sheets. This gives you an indication of the complexity of sea level science, that we have to understand dimensions and melt rates of ice sheets that existed 20,000 years or so ago. Because if you were underneath that ice sheet 20,000 years ago, the land subsided. When that ice sheet melted, the land uplifted. Conversely, if you were located at the margins of this ice sheet, you were uplifted 20,000 years ago and you subsided. And this process is why sea level in Norway, in Oslo, is significantly less of a problem compared to sea level here in Singapore. I'll show you the animations. The second process is even more complex to understand. It's related to the gravity of our planet. I just described how big Antarctica is. So at our poles, we have these ice sheets of colossal mass, so they have gravitational attraction. So water is attracted towards the poles. If the ice sheet melts, that gravitational attraction weakens. We did some simulations at EOS that if the Greenland ice sheet contributes 1 meter of sea level rise, well, the northern coastlines of the Arctic receive net sea level fall. But in the tropics, we receive 1.2 or 1.3 meters, a hotspot. Next, we come on to processes which we're really trying to address at EOS, which are the local components. Because they're very, very important to identify hotspots of sea level rise where we need adaptations urgently. So when we get down to local processes, these are currently unconstrained or indeed ignored by the IPCC because we do not have the capabilities. So on the top right, groundwater withdrawal. So if you're a coastal city, you're withdrawing groundwater for agriculture, economic, residential, industry. You withdraw it from the coastal aquifer, it loses volume, the land subsides, you get a sea level hotspot. And this is happening in Jakarta, Bangkok, and Manila extensively in Southeast Asia. Bottom right, tectonics. We live here in Singapore in a region that is the most tectonically active region on the planet. So when an earthquake happens, the land can catastrophically subside and uplift. These are currently not included in projections of sea level. And in between earthquakes, they gradually uplift or subside to try and reach equilibrium. And then finally, in Southeast Asia, and this is the element we're actually collaborating with our Norwegian counterparts on, is a project that looks at ocean dynamics. So the island archipelago of Southeast Asia is very complex in oceans and atmospheric circulation. And we need to understand this if we're going to provide local projections. So now let's just look through some projections. So we're going to use the latest data that came out of the AR6. We're going to look at N members here. So we're going to look at, and why I've picked these is because SSP 1.9 is the Paris Agreement. That's what we're trying to get agreements at COP26 to stay on. The other end is SSP 58.5, which is the business as usual. This is the scenario that we've been on for the last 30 years since climate models have begun. This is the scenario that we're on for the next 10, 20, 30 years, unless COP26 can be ratified. So let's show some projections. So in the red is business as usual, in the blue is the Paris Agreement. We've got pushing out to 2100, you've got sea level along the y-axis. On the graphic is the 50th percentile or the median, and in the boxes we have what the IPCC calls the likely range. So going from between the 17th and the 83rd percentile. So if we look at the blue, if we're looking at the Paris Agreement, the first thing to say is that sea levels will continue to rise. We have to deal with sea level rise. What we have to decide upon is what are the magnitudes and what are the rates. Because under the low emission, there's not a significant acceleration in the rate. You're going from today's values of around 3 to 4 millimeters towards the end of the century, 5 to 6 to 7 millimeters. And this keeps us below very important ecological thresholds regarding the survival of coral reefs, oyster beds, mangroves, salt marshes. Conversely, if you go to the high emissions, you're getting to rates that tip beyond those thresholds. You're getting a doubling in the magnitude of around 77 centimeters. And when we look at the 83rd percentile, the value crosses this landmark or is at this landmark of 1 meter. But please be aware that that is the 83rd percentile. That's not the 95th, that's not the 99th. We're not looking at a 1 in 100 chance. That's just giving you an indication of what's the upper likely range. Okay, what is Singapore? That's what we want to know. That's what the government here want to know. So what does Singapore's projection show? Well, if we look at the 50th percentile, it is remarkably similar to the global mean, only differing by a centimetre or so. When we start to look at the upper threshold, so the upper limit of the likely range, instead of being just over a metre, we're pushing it to around 1.2 metres. So if Singapore is approximate to the global mean, the sort of take-home message to you is that other regions of the world are not. Sea level has an unfortunate name because people think that sea level is going to be the same everywhere around the planet, and it's not. In Oslo, the 50th percentile for the high emission is very similar to the low emission for the globe. And the low emission has no net change. Why is that? That's based around our understanding of an extinct ice sheet that existed over northwestern Europe 20,000 years or so. So ocean volume and mass is increasing, but the land is going up at the same rate. So you have no negligible change in sea level rise. New York City is the opposite. Why is it greater than the global mean? Well, because New York City was at the margins of the North American ice sheet. So our knowledge of that ice sheet means that that area, the land is subsiding and our ocean volume and mass are increasing. And then we get to Manila. Manila's values are off the charts. They've got a low emission that's higher than the global mean high emission, and this is because of groundwater withdrawal. The rate of global sea level from about 1920 to 1960 was 2 to 3 millimeters around the global average. The increase in the urban area of Manila withdrew groundwater from its aquifer, and it's sinking at around 15 millimeters per year, and that's why you get those catastrophic values irrespective of what's going to happen at COP26. Now, this was briefly mentioned by Kristen. The other element of the IPCC was to look at what we call high-impact, low-likelihood events. Events that we know something, we understand the physics, they've occurred in the geological past. Just as a community, we don't know when we will cross the tipping points or thresholds. We know it will happen, but we don't know exactly when. But we started to model them. So Kristen illustrated this, that there are two processes that influence high-impact, low-likelihood events. And all I will just say, in contrast to Kristen, is that we have better animations than she does at EOS, okay? I think you can all agree. Her group may know the science, but we can do animations. Okay, so on the left-hand side, it's this idea of marine ice shelf instability. So Antarctica currently isn't contributing a significant amount of water to our oceans because it's buttressed by these ice shelves. But if those ice shelves become unstable and collapse, then the ice sheet can start to contribute to our global ocean. And remember what I said about the size of that ice sheet and how much it can contribute. On the far right-hand side is when you start to combine the physics of climate change with engineering responses of that ice sheet. That once you get rid of the ice cliff, once you get rid of the ice shelf, you get an ice cliff, and that will start to catastrophically collapse into our oceans. So we started to model this, and we started to do scenarios for Singapore. So Here we can compare the SSP5 business as usual with this process. If this process starts to occur as we think it will do if we cross the 1.5 degrees C threshold of the COP25 agreement, we get an increase in the global mean from 78 to 92 centimetres. And let's start to look at that 83rd percentile. It's nearly up to 2 metres. But this process would significantly start to increase when you go out to 2,150. The 50th percentile goes up to 2.1, and the 83rd percentile crosses 5 metres. Now, a third of Singapore is less than 2 metres above high tide. So you invoke this process, Singapore doesn't exist. And I know I love Singapore. It's why I moved from the US. I look out at your faces. I imagine everyone here is proud to live, work, and be in Singapore. If we don't agree to the COP25 and COP26 and the Paris Agreement, then your country's gone, as is every other island nation on the planet. So that's a sobering thought. But it shows the importance of the work that I'm very unfortunate I was not able to attend earlier today, but I was at other meetings to do with COP26. But the work that you do is so crucial to providing the solutions to climate change. I could say a variety of things, but we've been living through the pandemic. We're wearing masks. There is a vaccine. We'll get out of this problem. There's no vaccine for climate change. I'll say this because we can begin to melt this ice sheet in the next 30 years. It will take 100,000 years to regrow it. Doesn't matter what we do. We've locked in these problems. So please carry on your work, but do it because you need to do it. Do it because you want to do it, because you want to save this planet for yourselves, for your children, for society. It is so important. If you knew what I knew, you'd be very, very worried about what this earth can do. The slightest touch over a threshold, and it's catastrophic. Thank you very much.
Thank you very much, Professor Harton. I think he summarized it very well. Climate change is a threat and urgent. And I think for my personal takeaway, I should warn my folks in Manila to do something about it. Do you have any questions? I think, do we have time for questions? Or thoughts? Final thoughts? No? Berkester?
No, I think there is, what can we say? Ben, you put it in a perspective here, and I wouldn't say the encouraging words. It's scary, like crazy. And as I said, we just have to let this sink in. It's it's sobering. So I think that is that's the last comment on that. It sits well. It sits well. Thank you, Ben.
I would just. Well, Per Christie, you've known me for quite a while. I'm not a depressive, person, and I sit there with my big, glass of whiskey, drinking away the hours. I'm a fun person to hang around with. I'm very, very positive. I work at NTU. The kids I teach are phenomenal. We just need to give them the time, because they will come up with the solutions that will enable the proposals that you've seen today to be done at a grand scale. We give them the time. You make the changes on your personal lifestyle within your company. Each one of you, I would ask, for whoever you work for, do you have a climate action plan? Do you know what your carbon footprint is and methods to decrease it? So by 2030, you have your peak energy emissions. NTU didn't know this. And so I basically persuaded the president of NTU, Subra Suresh, to come up with he's going to carbon neutral by 2035, and we're now going to try and act on it. And now I can say that I'm proud to work for a company that's going to be carbon neutral by 2035. That's the type of thing. And then just to your point about I'm going to tell people in Manila, that's the other thing. Education is key. I'd like each one of you to just tell somebody this evening, oh, I saw something on climate change. It is urgent that we take action. And just do and you could do things personally. I mean, I have enough money that I bought myself a hybrid car. I could buy myself an electric vehicle because they're not that, we don't have one charging station, but I did that. My daughter made me turn vegetarian 2 days a week. Okay? But that made a difference. I was brought up, meat on the table, twice a day, 7 days a week. And my daughter educated me because I was like, I'm okay with the animal rights, and then she told me about climate change, and I changed how my diet. And you can make those differences, and we can save the planet. Give the kids the chance to come up with the solution. So I just wanted to end on a positive.
Singapore's answer to Greta Thunberg. Thank you very much. Thank you very much, Marianne, for also moderating this one. I'd like to call upon Po Seng Lee, who is the director of the Energy Studies Institute, a partner here for this event, to give us the concluding remarks. Please, PS.
We'll start by expressing my appreciation to Innovation Norway for sort of organizing this very important and timely event, as well as the Norwegian Embassy. Also, the appreciation to UIT for working with us to make this event possible. And my personal thank you to His Excellency, the Ambassador, for giving us a very motivating opening speech, but Krista for putting together such an excellent event, despite the trying time, as well as Professor Olsen for giving the insightful keynote speech. Also, I'd like to thank the Norwegian Embassy staff for working behind the scene to make this event possible. So Norway has been a consistent and long-term partner of Singapore as well as ESI. ESI hopes to work closer with our Norwegian friends, not just in the Arctic space, but in the wider clean energy sector. ESI is always looking for collaboration opportunity, and I'm sure this extends to other research performers in Singapore. So next, I'd like to express a thanks to our Singapore partners, right? In particular, the Singapore Ministry of Foreign Affairs, Mr. Sam Tan, the Special Envoy, for supporting ESI in our Arctic activities. We will continue to support our government Arctic agenda and help to facilitate interaction with the Arctic Council member states. Please do not hesitate to let us know what else we can do for you. And last but not least, I'd like to thank all the speakers and the audience for participating in this conference, as well as to the hotel staff for making it possible. Thank you very much.
Thank you very much. With this, we close this event. Thanks to all of you physically here. It's fantastic to be able to come out and meet people again. And thank you very much for the ones that were attending by the web. I wish I could say that now we can sit down and have dinner together. But you know, the rules and regulations are that we had to then separate into tables of two, the group of two, the famous group of two. As a compensation, there are bento boxes at high quality for each of you. But according to Velen, it has to be eaten within 2 hours. So probably there's something fresh and good and nice on this one. So I'm terribly sorry we can't offer you food here, but bring it home and enjoy. Isn't that right, Velen? Yeah. Okay, thank you very much then.